If you want to let people in now, Dave, I suppose.
Yeah, I'll flick the switch. Okay.
Yeah, might as well, because it's way past 7. So.
I think everybody's in who, I don't think Sean's in.
Oh, okay, well, let's get started before Sean gets in. Otherwise, it's
start before that goes
we're
on.
never going to finish. Right, FI on timekeeping. Apologies to everyone, by the way. This is, I spent pretty much half of my birthday yesterday and the weekend writing this and a few hours tonight because I didn't want this to go 10 hours. It easily could, but it not. We'll aim for the 2 hour mark. So,
yep.
Right, Dave, you just chip in when you want, and John, you chip in. Either way, let's get on. Let's go. Okay. Right, so can everyone see the screen, by the way?
Yep.
Okay, just to be clear, because my screen's a bit funny. Right, so today we're going to cover DNO intakes. The reason we're covering DNO intakes is, as you'll see today, too many of them. We go into too many installations and we are trying to spend a lot of time figuring out what the supply configuration is. Now, I'm going to put my hand up and say 20 years ago, when I was doing it every single day, it was very simple to spot a TNCS, a TNS, and a T. Well, TTs, you had to find the rod, but it was pretty simple to identify a supply type. Now it would appear that it's getting far more difficult, and we're getting lots of weird, funny configurations and.
Yeah, and I think fundamentally the same 3 pictures have always been represented of these earthing systems for over 20 years now. It's just been a re-edit of the same 3 illustrations, and sometimes they just don't look like that anymore.
So what we're going to do today is we can't solve every single person's problem for them in this webinar. And for anyone watching on YouTube, this is more about a recording of what the engagement with everybody is, but more importantly, where to go away and start researching yourself. So Dave Betteridge is going to be salivating at this because there's a lot of knowledge in here. We're going to give you access to it where you can publicly go and find it, read for yourself so we can continue this debate because there is going to be a part 2 to this. And the part 2 is when we're really, really going to commit career suicide for some of us.
Yeah, definitely.
Trust me, this is where it ends up.
This no more after that. Can I just say, some of these documents, are they publicly freely available?
Oh yes, they are.
Can you highlight that when you find them? Because some you've got in your subscription, and can we just emphasize which ones we can go and get for free so the guys can actually do that?
Well, I've actually screenshotted it, so you can just screenshot this. So,
awesome.
Right, let's go in. So for everyone who's watching, whether you're 20, 30 years in, doesn't really matter. We all know these codes, and they cause a lot of confusion. Now, the Codebreaker book, one of the things I like about the Codebreaker book is, and this is not an advert for it, even though my name's in it, this actually does have codes for the DNO intakes. And why not? The DNO intake is most certainly something that we need to inspect because it's in the schedule of items inspected. It's imperative for the applied safety measure, is it not? We do a ZE test, we do a PFC test. We make sure there's sufficient energy that is generated from the external earthing to trip circuit breakers. And obviously we look at the intake, the origin, the earthing, so that we can effectively have earthing potential bonding and all that good stuff. Yeah, so it's imperative. Now, in the wiring regulations, I think it's 1110, it says the DNO equipment is exempt. I think that's total rubbish. And if you had a chat with a lawyer would probably say, well, if you're relying on something that's exempt from the wiring regs for the safety of your protective measure, and you're inspecting it and signing off as part of your installation it's safe, is it actually exempt? Again, it's an opinion. I will say this, it's an informed opinion because I've had these discussions with lawyers, which was quite awkward.
I think legacy of training has always kind of, especially in testing training, has always kind of highlighted, supply characteristics are measured and inspected, but we have that point where we have consumer installation on the load of the meter, and then we have the supply intake, and obviously 7671 ESQCR, separate standards. And so a lot of guys are trained under the opinion that the meter itself has got nothing to do with them to observe. And it's only in recent editions of BS767 where the condition of this equipment has started to become, instructed.
So from a legislation perspective, most of us know the book on the left, wiring regulations. It's a guidance note. Compliance of it is presumed to be compliance of electricity at work regulations, or the various clauses within the EAWR. EAWR itself is a secondary piece of legislation which sits under the Health and Safety at Work Act. There is also these regulations on the right, which is the, has anybody ever come up with a decent nickname for them?
I just call it ESQCR, and then it rolls off the tongues. I've said it so many bloody times.
ESQCR. So yeah, the Electrical Safety Quality Continuity Regs 2002. They have actually been amended in 2005 or 9. And if you go online, this is a screenshot of the online copy from about 25 minutes ago. That's literally when I screenshotted it and put it in here. Henceforth, we're a little bit late. So this is the highest piece of legislation for those DNOs in the land. And hang on, let me just on my screen because it's annoying me. Yeah, so this is the highest piece of legislation in the land, and all it does is it confuses people because that regulation 1110 says that everything that's under there is exempt. I really would argue that maybe that approach is going to have to change.
Something has to.
And the argument I'm going to put forward is if we are becoming prosumers, and if we are potentially going to introduce foundation earth electrodes or other devices and look at OPENs and all this other technology, we are slowly merging. I mean, I was speaking to a chap in the DNO the other day, and we know the DNOs are looking at whether some of the EV technology out there actually complies with the intent of this, which will be another webinar which we do on EVs at some point when we actually get an answer from them. For this webinar, I have spent the last, is it fair to say, last 2 months talking to the DNOs, the ones that do want to talk. Some of them have slammed the door in my face. That's fine. That's the beauty of research. You can go and speak as you find. So again, like with the wiring regulations and any of the former webinars we've done on domestic, commercial or industrial, which are available on E5 and Sparkyninja's YouTube, there is the regulations. Everybody gets scared, everybody argues over a code, but I thought I'd remind people here, there is a lot of advice given out by our industry of issue a danger notification to the duty holder, the person ordering the work. But we all know, and most conscious sparks know, that that person ordering the work, that homeowner, if it's domestic, they haven't got a clue. They don't know what to say. And then as a spark, you end up sitting in the house on the phone to the DNO. Can you get round here? I've got a dangerous situation, and it costs you 3 or 4 hours a day. The homeowner doesn't know any different, and some of them don't frankly care as long as it works. And this is where these 2 words in the speech bubble, duty holder, as a CPD activity, I strongly recommend people go out and start researching what a duty of care is and what a duty holder is. I think they're terms that we don't use enough. And when we're going to have any sort of engineering debate, where was the duty of care owed? Who was the duty holder? You know, if you look at Safe Systems of Work, HSG 85, it talks about the duty holder. If a safe system of work changes, the duty holder has a duty of care to stop and reassess. That's no different on the DNOs. And the reason we say this is on Monday of this week, 2 chaps died working for the DNOs, one in England and one in Northern Ireland. One was direct access to live parts and the other one was crush, which we've put the screenshot. It's on our Instagram page. So you can actually subscribe to the DNO intranet and get all these documents and all these bulletins sent directly to you, which is exactly what I have done as well. So I just wanted to remind people about the duty of care, because again, your defence regulation 29 electricity work regs is you took all reasonable steps. So for when somebody says, oh, it's not my problem, I ain't going to wait around, is it reasonable to wait a few hours? Do we need to build this into our pricing?
Yeah, I mean, going in a circle where I do like training with companies and I have to help them define roles and responsibilities. If you are electrically competent, you have a responsibility of that higher level of competence, and you can't just leave because it's now a customer's problem if they cannot exercise the equivalent level of competence to pass over that problem. So you have to support them to pass information across. And then if the DNO then received the problem properly, then you've passed the competence across. A customer, especially a homeowner, cannot be expected to handle the competence.
No, and I think
you can't just abandon them with it.
I think it's vastly and grossly unfair to do that, to be perfectly frank. Now, just on this one, I just thought for anyone who's not, who's learning, it would be interesting just to give a nice visual on how electricity is distributed, because this is the network. This is what is known as the grid, generated at power stations. 23 kV, it leaves the power station, goes out onto high voltage transmission lines. Supergrid voltages, 400 kV. It then goes down to 275. It used to be, the whole of the country used to be 275. And then in the last 20 years, it's gone up to 400 kV to create this, what they call supergrid.
Supergrid.
So 275, a lot of the larger stuff, then goes into what is known as a grid supply point. Some people know of them as bulk supply points. For major projects like Crossrail, London Underground, they have bulk supply points where they come in, they transform it down to 132. They then can manage that into 33 kV or 11 kV, depending on what the supplies are. Large factories, heavy industry, light industry. And then from 11 kV subs in the local communities, you then get your 400 volt feeders, branches, as they call them, going out with then T's off of each phase into residential properties. And that's where your electricians will kick in, whether it's three phase or single phase. So I thought I'd throw that little piece of knowledge in. There's some questions in there. How do you get them sent to you? I'll cover that in 1 second, if you don't mind.
Is that the URL you sent on WhatsApp?
Yeah. Yes. Yeah, I've sent you tons of stuff on WhatsApp. I forget how
one
much
was
stuff
a
I've sent you on
URL,
WhatsApp.
and then you can register for it.
Yeah, I think it's G82 or something like that. There is, each DNO has their own library online that you can go into, download back catalogue copies, and also subscribe to updates on safety bulletins and all the rest of it. So whether it's UK Power Networks, Scottish Power Networks.
The URL, the URL you shared was g81.uk.
G81, that's it.
So can I share that URL with the chat?
Yes, please. Yeah, go for it.
Do it now.
So I said about 2 years ago now, there was something called a DSO coming. I don't even remember, it was a LinkedIn article. Well, the DSO is certainly on the way. The standards are now being changed and adapted to start introducing the term. For those who don't know, a DNO is the likes of the UK Power Networks, etc. The distribution system operator is where the DNOs are going. And the reason they're going that way is because of smart grid. Yeah, the rise of the prosumer, the import and export of energy from all parts of the grid requires it to become a system, not a network. There is also something called a BNO, Building Network Operator. That's where you may have a high-rise building. And years ago, all the electricity distribution was wired by the power networks. I know I used to work at 3DF Energy, and they would wire the submains all the way up. And now, all of a sudden, they've turned around and said, no, so that you own the building, you own all the power distribution, we'll own the cutout and the main intake fuses, and that's it. So that high-rise operator, or social housing, for instance, becomes a BNO, Building Network Operator. They're governed by a standard called G87, but there's also ones called IDNO, Independent Distribution Network Operator, I'll tell you in a second, and EDNO, License Exempt Distribution Network Operator, and that's like the network rails of this world, because network rail are license exempt, they're a network operator, they generate, transmit electricity all around the country for railways. So there's lots of new terms and new phrases coming out. So let's just go into, if my mouse works. Here's a nice picture. Love a picture. So this is kind of the electricity networks as it currently stands, colour-coded, Scottish and Southern. We've got a large chunk of Northern Scotland and Southern England. Western Power have pretty much cut their way across country and down into the southwest. UK Power Networks, that's made up of the old Southern, London electricity boards and Eastern electricity boards. So there used to be, I think it was 13 electricity boards in the olden days, and they all had their own nicknames. Like Southern used to be known as, not Southern, Seaboard used to be called the Seaboard Mafia. Eastern Electricity were the greatest of them all, which, yeah, I'm personally biased there because I've lived there. But yeah, so there you go. And what you've then got also is your IDNOs. So who's heard of Energetics Electricity Limited or ESP or Independent Power Networks Limited, or the Electricity Network Company. Even UK Power Networks, who are in the southeast, have got their own IDNO. So you can go and pay them for their services. And then this is about, I think these DNOs de-risk their businesses by allowing private companies to operate on their network, because in their view, it's about regeneration, getting the network improved and all the rest of it. And also, so there's lots of new terms. Now, we weren't thinking about that 20 years ago, were we?
No. So are these gonna?
No, I know.
I mean, if once we go down the line of prosumer, are these things gonna? Is this drawing gonna look the same?
Yeah, but I think there'll be new drawings. And in fairness, I have seen a drawing, but I will. That's going to have to go in the next one, because again, it's time. These take hours to put together and research and etc. etc. So, yeah, possibly, maybe we'll go into who to get. Yeah, let me just forward on. Electricity Network have always been a great to deal with. Some of them are good, some of them are bad. So this is the company we need to speak to, the Energy Networks Association. And these are some of the standards that you can go and get. They're free to download. You can Google them. So, and this is ones where I find the arguments online quite bemusing. Energy Network Recommendation G12, requirements for application of PME to low voltage network. That's where you learn about criteria where they turn around and say, we will need an additional earth electrode at the end of every branch. And then you go, what's that extra earth wire sticking out for and going down with the cable? It's the earth electrode connection. But we don't know that because we don't read these standards. And we don't take time to understand the network. As you know, Dave, for the last 2 months, I've made understanding networks my day job, night job, evening job, and morning job. It's a work issue. So anyway, yeah, G81, Part 1, framework. So if anybody here is working in construction and you're asked to go on price for a new build estate, if you go to G81, Part 1, framework for designing and planning a new estate. So how you would do the earthing, it talks about solar PV connection, EV connections, all that good stuff. How you do the earthing, it's in these documents and they are free. More importantly, the applications and everything else that you need are within the energy networks. And the energy networks, for those who may not have heard of them, they are, as they put, the voice of the electricity networks. So all of those companies we showed you in the previous slide, they report or have a communications body. They don't govern them, but they kind of have like a joint industry body that they put staff into called the Energy Networks Association. One of the fascinating ones that I've seen, there's Engineering Recommendations, a Guide for Assessing the Rise of Earth Potential at Electrical Installations. Didn't know that existed. Interesting document. I'm currently reading it, by the way, so I'm not going to give you any more than that. So that's the energy networks. I'm now going to use, we'll get on some photos, by the way, and coding in a second. I'm now going to use UK Power Networks as an example, my local DNO. So they have their own method and means to comply with, say, G12. Okay, so it's very much a hierarchy of standards and how they interpret it. So you've got G12, then you've got, say, their earthing standard, which they call EDSO 6001. Again, all of this is free to download. You just got to Google it, go online, register for a UK Power Network account. You don't have to be staff. This is all free. So you can get their earthing standard. You can get their standard for LV power supplies. Now, there's one specifically for up to 100 amps, and there's ones like this, which is from 100 amps up to just 2000. So you can get various documents which will guide you. You can get design documents. So here is, if you can, the guidance for why we put meter boxes, 100 amp single phase cutout and surface mounted meter boxes. It shows the guidance for the bends, the size of the pipe, the layout. Please note in this little section here, the boards are now divided: meter, smart hub, isolator, switch, fuse. We are
this is a good reference point if you're thinking I've got on an EICR have a reference to make an observation against.
If you see a consumer unit installed you are in breach of EDS 082110 engineering engineering design standard for the DNOs. Now, the trouble is too many people at the moment are installing fuse boxes into these DNO meter cabinets. They're not considering IP ratings. They're not considering spacing, bending of cables, but more importantly, they're not allowing for the fact that the environmental conditions, right? The boards they're installing are not IP rated. We know these meter boxes always get damaged over time. You know, we're not considering about use, access to skilled, authorized persons, instructed persons. We're not considering much. We're not even really considering EMI. The fact of the matter is these smart hubs, they transmit at quite high frequencies. You put a little small EV, type A RCD or type B RCD. Have you done the due diligence? Have you actually said, oh, well, the emissions from that won't actually affect that? We know, we've seen videos online of people's RCDs tripping out when they put radios up near them, they trip out. They can be affected. It's electronics. You don't do it. You do not put these boards in. And we've ranted about this.
This again, something we need to develop with Paul Skirman yourself, where we talk about environments and the
environmental conditions, temperature differentials, all that good stuff.
Yeah.
Grouping factors, all of this. IP ratings of the boards. You just don't do it. Really simple idea, guys. Go and get a meter box, an IP rated Sorel box, Schneider one or whatever. Put it next to it. Drill a hole, some nice stuffing glands, bit of armored cable, make it look really, really nice. That's a nice way of doing it. Just do it like that. But again, the whole I haven't got space is used consistently for, well, what do I do? Do I turn the work down?
Yeah.
Yeah. Yeah. If you know you're doing it wrong, turn it down. Moving on, because that's a controversial thing to say. I'll probably get a lot of hate for that. So I apologize if I've upset you in any way, shape or form. I'm not trying to be a perfectionist. I understand there's a real world out there, but still find a better way. Cutout changes. So this is a great little document here that you can download from UK Power Networks. So if you want to know the ins and outs of a cutout, there is a guidance note that they produce with all of the information for the Henley blocks, how to do it, all the stages available. I'm not saying that Spark should do it, but the information of how they work on them is all available. So if anybody says there's a training course, there's stuff out there. There is stuff out there. There's lots of information. There's also, again, the ENA, the voice of the networks. There is also guidance on cutout types and ratings, which I believe Mr. John Ward features in one of their episodes. Don't you, Mr. John Ward?
You're right, yes, I think so, yeah.
Yeah, I think they borrowed one of your photos without permission. So it's only fair that we do the same.
We'll a response about that.
See that photo later.
Yeah. So let's go into it. What would we code these? So you've gone in. There's evidently been, someone was reporting there was a smell of burning. Run the poll, Dave. Let me get to the next photo. There you go, from face on. Code that. Still live, by the way.
There's a nice thing in the chat, actually, about Memra 2 boards are affected by smart meters.
Yeah, I've heard that.
Memra 2, yeah, I've heard that, actually.
Yeah.
I don't know. Have we ever actually found a document on that?
I'm going to try and get the head of EMC onto our podcast at some point when I get 5 minutes to talk to him. He owes me a few favours.
All right. I'm going to close the poll. I think we've got a fairly conclusive. we did have one troll here today.
Did we?
Well, there's always one, isn't there?
Well, look, we got a C2.
Really?
We've got 97% C1, 3% C2.
Potential. I like the C2, whoever it was. Well done. Interesting, yes. And no FIs from me today. Well, maybe there might be FIs. There might be FIs on this. So let's move on, because we've got a bit to go through, and there's a few little more gems of knowledge.
But again, an FI might be justified because of the causation as well, you see, with things like this.
Dave, you could be onto something there, couldn't you?
Yeah.
Yeah, you could be onto something. Let's talk about that a bit later, shall we? Thank you for reminding me of that. Okay, so next one, I've tried my best to kind of bring out the obvious. So I'm going to ask two questions. One, to code it, and two, what earthing system do we believe that to be? It's a nice, easy one, this one.
Okay.
C2 was me, Chris Raddock.
Yeah, this one, we got the pitch leaking out, which is that black substance, which when it's cold, it's completely solid. And it only flows out like that when it gets hot.
So why would it get hot?
Indeed. Why would it get hot? So this is more about thinking about what's going on there. It's not just, oh, there's some mess fell out on the floor. It's what has caused that to become into that liquid state and fall out onto the floor and make a mess.
Is it fair to say as well, JW, that the intake cutout is the first real place that heat impacts that supply cable? One of the things that, again, having worked for EDF, I always used to ask this question on buried cables and heat dissipation. I was always told, well, it's really cold in the ground, so they thermally, you don't have to derate a cable in the ground that often, because the first time that heat really affects them is when they come out into that supply cutout, where it starts to realize, oh, there's a big load on this. And over time, yeah, you're right, it's pitch. It's that's a cast iron one. That was from Mr. Lorimer, actually. That's from his personal collection. He donated that to me. I used that on a, I just thought it was a great example of just an old lead covered cable on PILC was used on TNS. So what has everyone coded it yet?
We've got pretty much 80% have had a go. We've got here 63% have gone C2.
Oh no, Daniel Casey. He has put, looks like TNS. Correct, you are correct. If I was looking at that on the electrical installation certificate, I would absolutely put that as a TNS service head. There is no doubt in your mind. It's clearly TNS. The configuration of it is TNS. It's just leaking pitch, which is horrible and disgusting. And once that pitch all leaks out, you then have the risk of arcing or a short on the metal case. And if you report it to the DNO,
fundamentally you've got an insulation medium that's escaping, haven't you?
Yes, you don't longer have insulation. It can be a loose connection in the head, actually. Yes, you're bang on. And I've just realised, Dave, that I'm missing a slide of a certain intake, which we could have used. We'll use it for the next one.
Yeah, next time.
Right. So, yes, it is. What has everyone put?
Yeah, so 63% went C2. And we had 11% went C1, 18% FI, which I think is your FI there, Paul. I think that's justifiable because, again, is this, some people have said, is it a loose connection or is it loading?
I think we've definitely got I mean, we must have Neil back in because someone's put a limb. Only Neil would put a limb in. Daddy Watts, nowhere telling whether TNS or TNCS now due to alteration. Well, yeah, that and kind of one of the points we are making in this is, we'll get onto it a bit later, but yes, from 7671's purposes, that is a TNS supply every day of the week. When you now go away and start looking at some of the documents we've just shown you, you will soon start to realize that there is no such thing as TNS on a lot of networks, with the exception of, and this is probably the best time to say it, TNS only exists if you have a private transformer now. There have been conversations about removing it from the regs in the past, but as long as there are private networks with private TNS isolating transformers, it will still be in there. The problem is the wiring regulations committees have not done sufficient, no, they've not undertaken sufficient acknowledgement of this issue and told people in the wiring regulations and the associated guidance notes. And we know, because we are quite nosy, that Ofgem told them in 2012.
Yeah, well, I mean,
you can Google it.
It's just funny that the information about the breakdown of the and repair works has been out there for ages. I mean, Phil or Daddy Watts found 7909 has got a comment on that, and that was published in 2011. So why has this not come into 7671? Or
this
even
thing about
just,
the
principle.
PME, yeah. This thing about the PME, it's on the electric vehicle charging course. It's actually in that if you get a TNS, you're supposed to assume it's going to be PME regardless of whatever else, unless you can get written confirmation from the DNO that it is TNS and will stay that way. But of course, that's never ever going to happen in any kind of situation. So,
is that written? Is that written in the Kenyan book, John, or is that from the course?
I think it is. Yeah, it's definitely in the actual the CNG questions that you've got. So it is actually in there.
Interesting.
That assume that it's PME unless you know definitely that it isn't, and it's going to be that forever. So certainly for electric vehicle charging, there is no TNS anymore.
But 7671 doesn't go down that avenue, does it? It doesn't actually doesn't say that to that effect.
No, it doesn't at all.
It's bizarre.
It's a bit behind. That's the problem. I didn't know that, John. Actually, I haven't done the EV charging course. Well done for getting 100%.
John's just got done his, isn't he?
Yes, that's the book there. That one.
No pressure. No pressure on me. But now, if I get 92%, the abuse that John will level towards me will never ever be able to be shown on social media. But right, yeah. So everyone's put a decent number. Here's another cutout, single phase this time. Again, what would you code that? And also, that strangely, oddly looks like a weird clip configuration.
What is this?
What does everyone think?
Right, yeah.
One of the things that we've been doing while you're all coding this is we have been, as we've been going through and researching, if you look at our Instagram, we've been screenshotting certain key things to kind of just tickle your fancy and inform you a bit more, because I've been reading BS 7430 as well in recent days, and there's some interesting tidbits in the various editions of that which seems to have disappeared and appear in a DNO document. And yeah, it's a bit like a spider's web trying to put together this narrative. And I also know the IET are researching this as well.
Do you think maybe another guidance document's on the way?
Probably, but I'm doing this research separately from them.
Another book.
Because
you
they
said
don't
earlier
want to listen to me.
So you hinted earlier on when we look at the ENA documents, that they have these, but they don't tell us. And a lot of times they do it because they make training from it, or they'll make their own publication from it, instead of just telling us where everything is.
Can we just stop here now and say hello to whoever in the IT is watching us on YouTube? Well ahead of you.
Yeah.
Anyway, there we go. Right, so
let's share this out. We have got C2, 62% C2, 1 C1, so 2% C1, and 17% C3, and 21% FI. I understand these FIs because we can see this, but we need to know more about the cause of this.
Yeah, and the thing is if you use a clamp meter, the clamp meter is only going to tell you what you're using at the time. And if it's the middle of summer, you're buggered. As you've rightly said, Dave, if you're ever really going to do any purist load monitoring of anything, you need to spend a week, and it needs to be done in the coldest weeks of the year to really understand what the maximum demand on that actual installation is.
Oh, yeah. You need to be there when it's under the most stress.
So if you're an electrical contractor and you want to make loads of money, Christmas time load monitoring, best time. Right. Anyway. Okay. So everyone said
most
C2s.
C2s. Yeah, C2.
Okay. That was sorry. There was a clearer picture of it there. That looks like a strange cutout, doesn't it, Dave? It looks old and phenolic-like, doesn't it?
Phenolic-like.
Phenolic-like. Yes.
Is a word, everybody. Phenolic. We may mention it later on.
That's the one with the face on the front, isn't it? With the nose in the middle and the two eyes.
Yes.
Yes.
The phenolic face.
I can't unsee that now, John. That's just spooked me.
Oh, you're going to see that every time you go to any of your places.
Yeah.
Got one, yeah.
Okay, so it's Mr. Phenolic, the cutout that's there's back. So we will get onto that later on. So okay, good shout. So this disaster, this mess, this horrible installation, John Ward recognises it straight away because it's mine. It's my house. It's downstairs. So what is that? What supply is that? Because there's evidently a BS951 clamp on it, but there's also a link into the DNO head. So it's evidently maybe a converted one. But what does everyone think? And what would you code that? Or if you saw it, would you code it? Is probably a bigger question.
There it is.
I'm going to throw out my thoughts when I first saw this, because this is in my house downstairs. When I first saw that, I thought, well, that was a TNS. It's been converted to PME. If I did code it, it'd be C3 in it just to remove the damn clamp from it. But I had thermal imaging done on this, and there was a loose connection in the fuse carrier. That was as I moved into the house. So they changed it for a GRP cutout, funnily enough. Why? Because it looks like one of those black phenolic cutouts.
In case people are wondering why we're going to make that black phenolic, it's because of information which we've obtained from various places which suggests that they may not necessarily be up to the required standards. So.
Yes, it's a very nice way of putting it, Mr. Ward. Yeah, there's a lot still to do on that.
Yes, that will be available at some later date.
Somebody's put there's no seals on it.
What did you do, Paul?
Honestly, Gov.
I when I was like doing full-time training testing, I would have gone like, oh, it's a DIY PME, so maybe it's a TNS that's failed, and they've obviously then hooked it in to create an earth that way. That's what I used to call this.
So let's change it up again, because this was what worried me, and it made me push my boat. That meter's rated at 40 amps max. That cutout was upgraded to 100 amp.
Did they change your meter?
No. So you could argue, and again, in the next one, we'll put a slide up that shows the lines of demarcation between the meters and the heads, because whoever I pay my electricity bill owns the meter. I just rent it from them. Now, meters are supposed to be recertified between 5 and 15 years. Average is 10. Now, if you look at the meter number itself, you can see just here, I don't know if you guys see it, 69. So that was the year that meter was made. It was 1969. It's supposed to be recertified every 10 years. And the last time it was certified is on the orange sticker, which is 1989. Now, I happen to know that meter is supposed to be recertified, and that was supposed to be done in 1999. So it's 21 years out of calibration. And I have been asked and offered many a time for a smart meter, and every time I have said, go poke it. But one thing I have asked for is a meter that is rated at 100 amp maximum load. Is there a risk that the metering equipment could potentially fail?
Would they do that, or would they just push smart meter on you?
They have tried pushing smart meter, but they can't force it legally yet.
Yet.
Yeah, that's the word, yeah.
Yet. It will take some serious legislative change, and any legislative change around energy, you bet your bottom dollar they'll try and force that in somehow. They're already trying to lie to people anyway about it at the moment.
Right, so
what does everyone think? 40
this is
amp max
interesting.
meter?
We have got an FI lead here of 51%. 51% FI, 38% C3, 8% C2.
I am loving this, because when I first saw that, that's all I did. I actually got, this is quite sad, I actually got the regional manager for the DNO around my house and argued with him over the state of the head and everything else around it. And he didn't disagree with anything I said, because he said, yeah, you need to get a new meter rated 100 amp. We'll put you in a new GRP one. And yeah, that's what they ended up doing. They haven't done the meter yet, because I'm waiting for a meter company to be sensible with me. But I don't really use that much load-wise. I just don't. Not at any one point.
No, I mean your gaff is mostly like electronic stuff. There's little demand there.
Yeah, it is. There is, and I can see the DNO down rating fuses as well at some point. And I think that's going to vary now as well. Any support on the tails? The tails, yeah, it's not my install. By the way, I'm just about to do this. So I'm about to change the board. So I will be putting in new coloured tails, double insulated, and all the rest of it. Most demand is when he's boiling his piss. Jesus Christ! Stop it. Okay. Anyway.
All right.
Shall we go on to the elephant in the room? That clamp.
The clamp.
Yeah.
Yeah.
Right. So before Mr. John Ward starts, I'm just going to give you a little bit of history. 1941 was the first edition of BS 951. It was then updated in 1948, and then again in 1986. Over to you, JW.
Yes, the definitions of that, which is what you've got there, which is tube or tube, depending on which country you happen to live in, is metallic conduit pipe, rod or tube, and then most controversially, the metallic sheathing of cables, which obviously does mean that nasty clamp we saw in the previous picture would have been allowed at some point in the past. Yep. That's metallic sheathing of cable.
Yeah. So 951 clamps were once upon a time fine.
However, that has now changed, and what was it, 20 years ago or something, that was removed, and now it just says metal conduit pipe or rod. So the reason there's a lot of them out there is because at one time it was perfectly valid and acceptable to use them for that, and subsequently it was removed. But of course, nobody went around all the places and decided to change all the clamps to a proper
Well,
type.
you're looking, John, at nearly 50 plus years of allowing Tembi clamps to be used. Now, I remember during the late 90s, I knew quite a few jointers, and again, as I said, I've worked for EDF. There was quite a few single phase installations where when they were going around and retightening them or putting new ones on, they were blowing up, over tightening, etc., weak cables, deficiencies, just age, external influences, etc. So it was deemed not a safe way to do it. So there you go. So for anyone ever says to you, no, mate, they're not allowed, they were allowed. And this is where the engineering logic of you, when the network was created and when you took it on, you had to take it on and maintain whatever earth connection was there. Now, because their processes have changed and the standards have changed, doesn't mean they can palm off the responsibility of maintaining that earth onto you when you don't own the equipment. That's on the network operators. We need to be a little bit smarter in our arguments and our debates. And that's why if anyone wants to screenshot that and use that to beat the DNOs up with, by all means, again, Safety Quality Continuity Regs 24 Part 1. There's actually about 4 or 5 references to the need to maintain existing infrastructure across that document. But if you then go a bit further, 2009 edition, metal conduit, pipe or rod. So that's where we are now. And that's what they'll use. They'll say, nope, it's not, BS 951's not allowed on a cable. Absolutely, but it was. And you, the network, use that to connect my electrical installation to the general mass of earth via an older type. So you have to maintain that. Now, if it's not safe, you need to find alternative means, which can be used via these spring clips or digging up the ground outside, isolating the cable, connecting in the head, etc., etc. There are other means we have to take. They won't. That's what Daniel Casey says. And this is the argument you need to have. So what you need to do is you need to do exactly what I did and say, right, who is the field manager? You need to ring them up and say, who's the guy responsible for my area? Find out who he is, speak to him by name and say, this is my problem. I'm not going away because I see this all the damn time. Trust me, he won't want you ringing him up every 5 minutes, because my one didn't. And the first phone call, he couldn't argue with me at all. He couldn't, because he was like, oh, right, okay. And when he came around my house, I showed him a copy of the old one. And he went, geez, even I didn't know that. This is the trouble. These DNOs are under commercial pressures to palm off cost onto the electrical contractor via the consumer and the homeowner, and it's wrong.
Oh, Daniel's just said that there. They have some bullshit form they use to fool unsuspecting customers into paying for it to be converted to a BME. So instead of committing to their obligation to maintain what they've had, they're trying to fool the customers into paying for it.
I have seen that form, and I'm actually disturbed by it, because that form was evidently written by someone in a process department that has not had sight of the fact that the network that they inherited, sold as seen, in that condition should be maintained as that condition. And if they don't have records, which we know the DNO have terrible records, the duty holder is on who?
Well, they've claimed ownership of the safe system. They've got the
electricians have always been told as exempt. So there is a grey area here, and the duty of care on their equipment is on them. So yeah, anyway, I thought that would be a nice one to just break this up with. Right, back into it. Coding, identifying. What do we all think? Again, paper and so you get lots of different variants of the way this is done. It's almost a jointer's preference. Here's an interesting one. So you get a lot of intakes where you get little stringy bits of aluminium connected into sheaths and heads. Now, just be wary, some folks. Don't cut them off, because the BT lines, at the end of their circuits, they would actually run a little small squiggly aluminium cable connected into the DNO as their end of circuit earthing. But loads of electricians have gone and cut them off. This is something, I think what's happened here is there's obviously an old copper clamp there, and what looks like a telecoms earth, and somebody has used that to connect the earthing conductor to via a connector block. So what would you code that as? It's obviously a DNO job, obviously. And if you dig out their standards, you'll see there are thousands of standards on network conditions and various other bits. And there's even a standard on changing the cutouts, by the way, and how they're supposed to do the earth connections. So what does everyone think? Corrosion of cable, not correct for that size. How to calculate the CSA of that? It's a good one. Personally, I know what I would do, but I'd probably put a crimp lug on the earthing cable and connect it in. But
right. About 80% voted. We have got C2, 64%.
Yeah, I think if you looked at 7671, could you say that connector is not under the connection method is not putting the conductor under strain, given the fact that the entire installation relies upon it for safety of operational and protective devices?
Yeah, we need the adequacy of that connection is definitely.
If you look at the PME guide that we looked at earlier on, there are lots of references to a minimum 16 mil to connect the supply into the supply cable. So, and that's in a lot of the DNO PME guides now. So yeah, C2, I'll go with that definitely. Here's another one.
Okay.
Interesting. Again, a metal cutout, looks like it's a JW3 if you turn your head upside down. Which is a weird one. One of John Ward's old one, maybe. No, this is lovely, beautiful vintage colour. Three-phase supply and neutral. Decent, chunky, looks probably like a 35 mil conductor there. And they've obviously left a conductor from that earth block, the Henley block. But instead, somebody's obviously come out and over time effected a repair and just left a braided aluminium strap. What do we think? Do you think that's suitable, sufficient? Do you think we need to remove that earth? What do you think, guys? That a new Bluetooth earth?
Yeah, Daniel Casey's but they're busy writing, thinking all metal cutouts get replaced if you call it in. Well, some of them definitely would. They don't necessarily come rushing out to replace all of them, because it depends on how dangerous it actually is, because some of them can be and others may not be as dangerous.
So it's a valid point, Mr. Casey, and one thing that Mr. Casey needs to realise is there is now a risk assessment for cutout changes, and if it is a metal one and it is not leaking pitch, or there is no signs of thermal damage and there is a sufficient earth connection, it will be left. If it's kind of weird, because I reported one the other day and the guy came straight out, done a risk assessment on it and actually said, oh, I'll put this in for a couple of weeks, it's fine. But it does need to be done at some point. Again, the jointers are always busy. They're all DNO guys never sit on their backsides. They're always digging up streets because the network's aging. For me, what has everyone said on the coding?
C2 it's going to right now.
Ooh.
44% C2. 22%.
Oh, it's a really divided one. See, I wouldn't C2 this. I would C3 this as a maximum. My first thought is FI, shoot me. But the main earthing terminal, the connection point, is that Henley block on the top left.
Mm-hmm.
So if somebody's left that for the DNO, assuming that they would sweat it on or put on a clamp, the DNO haven't done that. You can see the DNO have sweated a braided, flexible steel tape and then connected that into that main earth terminal. Now, interestingly enough, the insulated Henley blocks, they're provided by the DNO and they're deemed DNO equipment under their own standards. So it's another interesting one. So evidently an electrician has gone in there and he's connected that and then left it for the DNO.
That's what it looked like to me. It looked like that earth had been left for the DNO to connect onto.
It has, and the DNO have gone, sod that, I'm not using that, mate. Why would I use a solid, hard copper cable when it's an old lead that I have to manipulate and sweat a new one on? So they've left that. And in all fairness, if you do an adiabatic on it, it's probably fine.
Yeah.
And the thing with that as well is that if they put the proper roll spring on that, you can't connect that copper wire to a roll clamp because it's not designed for that. So whoever left that obviously wasn't aware of that possible problem, because there's the only way you could attach that to that lead pipe is one of those nasty old BS951 things, which of course you're not allowed to use anymore. So
good old HV Day sweating thimbles. Yeah, they do occasionally do stuff with lead. Live unearthed DB metal encased equipment A17 fault code emergency from Adam. Live unearthed DB metal encased. Right, okay. Fair enough. I think he's suggesting that picture shown is not earthed. I think it is. Pretty sure it is, but
I have unearthed TB metal encased equipment A17 fault code.
In all fairness, I'm to blame for this because I've forgotten how many people have sent. I've had probably about 300 intake photos sent to me.
Yeah.
So I can't remember every single one of them. Oh, there you go. Actually, there you go. Haha. There's a larger picture of it. Just a step back. So there you go. It's a reasonably newish installation there. New intake. Tails for a new meter. New tails in there. It's just been left. Just been left. There you go. Someone's been working on the old stuff and they thought, nice chunky earth. Don't want that little thin bit there. Leave it for the DNO. Effectively what it is. I have actually seen people lug these and bolt them onto the casing screws. I've seen that before. I've seen Sparks actually cut off these little, what they consider straggly bits of wire, and then bolt it to the metal casing of the cutout. I've seen that done on a lot of occasions. Not good. Ring the DNO. That's Sparks interfering and manipulating stuff that shouldn't be. Here's another interesting one. This was in a feeder pillar cabinet. This is more good old-fashioned spot the hazard. And there's the hazard. So what would you do there? So you've obviously got a 3-phase cutout on the left here. And what you've also got here is another cutout, single-phase one. But what would you do with it? What would you code that as? Obviously, there's been some jointing gone on because you can tell from the box that they've obviously jointed smaller cables to big cables. So there's obviously some long lengths of run and stuff.
Is this as found?
Yeah, this is as found.
Okay.
But again, it's a separate small little DNO issue. ZE over 5 ohms, half diameter pi squared. Saw that recently. There's some good conversations going on in this chat room.
Yes, yeah.
That's mine. 3-phase system. There you go. Way oversized, long enough to be trapped in FP door. Scary. So different earthing systems. 200 amp fuses on that too. It's just a mess, isn't it? Really. There's a lot. There's a number of codes you can put in on this. This is the problem. There's a number of codes.
Is this one of the pictures sent to you?
Yeah.
Okay.
Yeah, even the bending radius and some of these cables going into the switch fuse and aluminium conductor cables as well. I can't see any metering on it. Just looking at it, I don't understand how the DNO would even allow that to be connected. To be perfectly frank, but then again, one of the issues you'll find is there's a lot of installations where there are DNO intakes and there's no metering because the DNOs still haven't got a proper record of everything they've got.
Those are the covers sitting on top of the joint box there on the right.
Looks like, that's why I asked if it was found that way, because it looks like the covers are there.
Well, that's what I got sent. I can't. My eyesight's shot. There is a cover of something. I don't know what it is though.
On there, so.
Struggling to see. I should have
So
zoomed
again,
in on that
if this is DNO equipment and you approach it and you find that a cover like that is off, are you supposed to fit it on? Are you supposed to touch it?
No, you'd see one that, wouldn't you?
So you want to report it?
You'd see one it. If you opened up a door and you saw that, yeah, I'm hoping everybody would be C1 in that straight away. But again, you look at why is there no metering, bending radius of the cables, space and clearance around the cutout, enable it to be accessed and maintained.
I see so many bending radii now that are just. I mean, it's as if electricians just seem to have forgotten.
Bonner's highlighted a good thing. Reduction of CSA in that joint box. This one here, the red, yellow, blues. That is ridiculous. It's similar to that one we found the other day on the PV, where you had the 6 mils in the comb trunking jointing onto like 70s and 90s, and just made no sense. Take pictures, run through all the issues with codes that are applicable to the different items. From Daddy Watts. Yes, I get you, Daddy Watts. Don't worry, there'll be more of these. I think there's going to be more effort required at weekends as well. Oh, sorry.
Let me just end the poll in chat. You're all right. Everyone's gone for C1 really. 57%.
Yeah, pretty straightforward. It's that obviously live parts right in the way and can't really avoid them. So
yeah, 29% have gone C2, 7% C3, 7% FI. But yeah, it's if you see the covers are off, Should you put them back on?
I would.
You would?
I would, but I've been trained on intake equipment.
Yeah, so there's the difference. You
That's
know
a-
what parts.
right. So should an electrician that is thinking that's
Oh
DNO
God, no!
equipment?
Listen, I'll tell you now. Any electrician who hasn't had any training by a metering or a network organisation shouldn't be touching it. Simple as that. The only reason I'm saying I would is because I've actually been through the 5-day training. 5-day training. I've been through it, and I know kind of what the risks from working on cutouts and metering equipment is, and it's yeah.
An electrician.
Would an electrician? No, because they're not familiar with the equipment.
Right. So in this
It's
situation,
familiarities with the equipment.
right, exactly. So in this situation, if this is in a cupboard, we would just close and try to keep that secure. If it was readily accessible, what would you do?
Oh, if it was readily accessible, I'd put a barrier between it. I'd find somewhere putting a barrier. If I could figure out how to put the cutout in, again, that's part of the CPD.
Barrier, signage,
Barriers, signage,
communication with the client, and immediate contact the DNO.
Yeah, all that.
Yep.
Absolutely.
Awesome.
What's everyone said? C1, C2 is good mix there as well.
Yeah, C1, C2 is good mix. Let's move.
Right, next one. This is a picture that got sent to me on an intake. I think there was a question raised with this one. Yeah, it was about the earthing, because some people have never seen this before, and this makes me feel really old. So for everyone watching, that on the right is a good old-fashioned time switch, and basically what happens is you take a supply out of the DNO head, you then take it into a little fuse, it then feeds into the time clock, it then loops across and back into the meter, and that just sends a little signal to say change that from single to second rate. Basically, so your economy 7 or whatever, and then your earthing terminal is obviously a connection into the side, which is a connection into the neutral. And it was raised of, I've never seen it like this, but if you also look in the photo on the left, is where the confusion is, because what you can see is a Tembi clamp on the cable. Tembi clamp indicates TNS. That connection there in the right hand side of the cutout indicates PME. What is the supply characteristics? So, what do we think? And what do we code? It's a cracking one.
Yeah, those time switches, the actual thin wire that comes out, the 5th one to the meter, is actually a switched neutral, just to be controversial there. So it switches on that onto the neutral to switch the other rate, and if it's not connected, then it's on the primary rate.
Oh, yes. Jesus Christ, John, I've got a good eye. I need to get new glasses badly. My eyesight's going to pot.
That fuse at the bottom, it's quite unusual to see those, because on half of those, fine, there's no fuse at all. It's just wired directly into the supply with no fuse.
I used to fit them years ago. I did. I used to fit them when I was younger, and I was working days and nights. During the day, I was crawling under people's cupboards, replacing blown fuse, fitting them, wiring up these old time clocks and stuff like that. I love those little ampies, these little 100 amp digital ampies. They were a pleasure to fit. No more awkward space issues. They were just great. You take out these big clunky things like that, replace them with that. You can see where the old one went. There's the screw that hung it up by. But yeah, so what do we think? Do we think it's a TNS? Do we think it's a PME? What do we declare it as?
Well, as a couple of people have suggested, maybe testing each one to see what you got, because the polling has picked up an FI on this.
That's a good one. And I would actually say on the polling, it's an FI.
62% FI.
So, yeah, no PME label. Yeah, because the PME labeling is really weird. They've only just revised their standard to mandate PME labeling now, which is bad, because they were able to get away with not PME labeling it before. I would suggest that there was a TNS there at some point. The TNS, somebody has probably made some form of effort to put a bigger, thicker conductor on. And then eventually the DNO have come out, and they have also PME'd it. However, did anybody spot the white painted cable that goes down the surface trunking? Can you see that? Going to throw more at you. This is a complex one. This is quite a complex one. But there is a white cable. Please tell me, everyone, if you can see this. But where my arrow is, there is a white cable that comes out the connector block as well.
Is it painted white or is it white?
It's painted white. As you can tell, it's the same color as the walls.
Right.
So somebody's painted that. They've evidently renewed the green and yellow at some point. It does go to an electrode. End of line. Bang on, Chris. So there is a lot in documents. There is, if you go back to 1992 even, the London, Eastern or Southern Electricity Boards produced these PME guides, the first of their kind. And anything that was on a branch, which was a branch is like a radial off a feeder cable in the street, anything that was end of line that had more than 4 homes on it, at the end of the line, if it was PME, you would put an earth electrode at the end of line in case of a lost or broken pen. And that's what that is. That's actually an earth conductor down to an electrode at the source of supply. But everyone assumes it's TT. And that's where it gets really complex. TNCSTT, yeah. That's where it gets really complex. So for me, what you've got here is you've got what was a TNS, or someone has attempted to assume it's TNS, but it's actually a TNCS with an end of line earth electrode. All of that is the DNOs. But it's just, you would think almost it's TT, TNS and TNCS. This is why I find this an amazingly interesting installation, because it's fairly evident that electricians may have played around with this a little bit.
Yeah, and it's just frustrating that they don't have a dedicated label on that.
Oh God,
that conductor to actually, inform us.
It's also that black. It's that black material again, but it's not the happy smiley face black material guy. But yeah, so there's a reason behind this. This is a cracking photo. If anybody wants these pictures or presentation, let us know and you can have them. And there you go. There's it a little bit clearer. You can see there's a conductor. You can see the clamp on the cable. I personally think an electrician's put that clamp on. Doesn't look like a DNO have done it. That definitely looks like a PME cable. It's so thin and skinny.
Yeah, I mean,
been painted.
Why did they put that earth on there then?
That to me looks like a late 70s PME install where someone has gone, oh, that can't be right. Stripped it back, clamp onto the armor or the concentric, gone, there you go, job's a good one, not realizing. And this, they probably thought it was a TT and they thought they'd convert it to a TNS. Who knows? But there's a story of many, many weird things going on there. Older PME with non-informed Sparky bodge. Daddy Watts has got it right. Bang on. But it's fascinating because as Sparks, we don't get to debate installations like this. This causes us so much confusion. That causes us time, which causes us money. More importantly, how do we advise accordingly? How do we engage with the DNO? So those standards that we introduced you to earlier on, you'll start to see diagrams, or on our Instagram page, you can see diagrams of network branches where you've got single neutral earth cable jointed to a PME, combined neutral earth, and then there's electrodes at the end of the lines. And it's all explained in the standards. But for some weird reason, Chapter 54 doesn't cover all this.
It doesn't, does it?
No.
Marcus said, are electricians allowed to test this electrode?
Technically,
we're not using it for an RA.
Technically, yes, we can. And the reason being is that earth block is the customers, not the DNOs, because the DNO's main earth terminal signed there.
Yeah.
Because the PME earth terminals have to be insulated under their own standards. So this thing, if you provide a 4 or 8-way steel earth block
and a label,
they will not connect to it.
Yeah.
They won't. And this is why they're providing separate Henley blocks now, insulated Henley blocks to connect into. And there might be a reason behind that even.
See Daniel's comment now. We're so self-indulgent sitting here looking at this.
We are self-indulgent. I know, it's great. But yes, yeah, it's good. I thought it was a great one to go through.
It is, and again, it's just one of those things that unless you do your research, you're not going to know from the industry. The industry is not going to tell you. You're sitting in front of that, and you just don't know unless you do the work yourself.
But more importantly, I think it's really good this peer talking as well and debating on the chat. So anyone watching on YouTube, we're not just talking amongst ourselves.
No, there's a good, how many of us are in it right now?
I don't know.
56.
Here we go. 56 Sados on a Wednesday night.
56 of us self-indulging.
Self-indulging. Right, here's a good one. So this is a picture sent to me. This is Scottish Power. Now, this is just a catalogue of improvements, but again, it's that nasty black phenolic type cutout.
Yep.
Lots of corrosion, lots of rust, probably coming from water seeping through cracks in the wall. You've got obviously, the lidding's missing. You can see there's a separate earth there. Somebody's done a nice job though, trying to label it all up. And
it's been an effort. There's been a professional effort.
There has been a professional effort there, without a doubt. Look, there's an isolator and stuff like that. The neutral is separate. But if you were looking at that, what would you say the earthing is? Now, I'm going to put my mouse where the earthing might be. But how would you assess that? What coding would you give to that in general? Because there's a few there. But just on the supply characteristics, what would you mark the sheet it is? And how would you code just that intake? Because let's be honest about it. Every single one of us, when we go into a house, the first thing we do is check the bonding and the earthing. If we don't, we should be leaving. And within 10 minutes of looking at the intake and the board, we generally know whether an installation is going to pass and fail. That's not to preclude us doing the inspection or doing the testing. But generally, your intuition generally is most of the time right. Unless it's IBS, then it's just stomach twitching, but you can't help that. So what do we think?
All right, a couple of comments saying, is there a fuse neutral? Is there a full fuse?
Good spot. Good spot.
Yeah.
This is an old one. I ran out of my handy wipes. Bad night for TV. What does everyone think?
All right, let's got 6% have voted.
I'll tell you one thing I've noticed while everyone's doing this. I reported a DNO cutout with a hole in the top. They now fill them with putty rather than a plastic insert and have them go into it and tighten up a screw. They now get a putty, an insulating putty. They mold it in their hands to activate it, and they stick it in the holes.
Yeah.
And I thought, you lazy bugger, just change the cutout. But hey ho, anything to reduce risk to the operatives, I suppose.
Okay. A few more have just voted. Let's have a look. C2, 54%. 11%.
Like plumbers, mate, yes.
C1.
But not plumbers, mate. Yeah, C2, it's a special putty from the DNOs. Again, if you want to know what the putty is, there's actually a catalogue of all the approved products that they have online. It's amazing how much knowledge of the DNOs is online. It's frightening when you can, trust me, you can start going down that rabbit hole and come out 8 hours later for breath.
27%.
Agree with that, C2. But I'd also throw an FI in there as well. It's definitely a bit more work. I'd definitely be making a phone call to the DNO and say, look, hang on a minute, lads. Is this right? There's a lot of rust and corrosion here. You've got a possible fuse neutral there. Yeah, I would definitely say, and FI would be my first choice. On the rusted trunking, C2 makes it C2, but on the DNO cutout, definitely an FI on that, to be honest with you.
Okey-dokey.
And yes, they are single insulated tails. And yes, the trunking lid was missing. So no mechanical protection as well. So yeah, C2, I think everybody's pretty damn right. C1, if there was a small child or something present, not that it would be on a three-phase cutout. Who knows, people with small hands. Trunking fill ratio not right. Yes, it's too packed. It's a bit of 2x2 on a three-phase is never a good idea, really, is it? Okay, let's move on. So here we go.
What have we got here?
Well, this installation is connected to PME system. It's a little bit of a different one, this. If you, can you see a couple of codes on it? Just looking, because remember, we are coding intakes. So this is a good one. We know it's PME because somebody has used slotted screws. They're not completely level. Yeah, I just hate that when they're at different angles. Tails.
Boils it, does it, mate?
I'm never saying that again. I'm never saying that word again. Yeah, there you go. So you strip conductors there. On
Daniel's
the tails.
pulled that one up straight away. Exposed insulation.
What about on the right hand side here? Okay, let me go back a bit. So I've got that cut off there. And I've obviously got, so there's an old earth connection there into the terminal. And this is obviously a new one, a bigger one. Interestingly though, these cutouts were available for a number of years, where you would have basically plastic around the side and then the exposed earth connection on.
Yeah.
You don't see many of them anymore, because obviously they don't comply with their current standards. But I just thought it was really interesting. This is a cutout because you've got basically the cable comes through 2 layers of heat shrink on the cores there. You know, most people that would be behind mechanical protection again. But a lot of them, they're just these single floating cutouts with an exposed earth. So what would you code it as?
Blue phase as well, with a little blue disc there.
It is, yeah.
Other colours are available.
What do you make of that? Ben,
I would argue,
Ben's good.
See, for me, I would FI the cutout. I would ring the DNO and say, are you still happy for these to be used? And then the duty's passed on to them. And I'd probably see to the tails, just if it's in a home and there's children present and all the rest of it and it's accessible.
Yeah, David
needs a little bit of TLC.
Put, about the voltage on that neutral or earth connection could be different from the true earth that someone's standing on.
Yes, it could.
PME.
Yeah, it could, without a doubt. It could indeed. It's a good point.
Okay.
What do we think?
We've got C2.
C2 is good.
69% have gone C2. 22% have gone FI.
Yeah. Oh, I could. Yeah, definitely. It just needs a little bit of TLC and a little bit of duty discharged. Not to coin a corny phrase, but
just a couple of C3s.
This is a classic. Now, I have found loads of these at the time, and you can just see 1974 written across that, can't you? Really, danger live mains. And someone went, great job that. 30 years later, somebody's probably moved that just to get that big clunky earth in there with the neutral. You know, not to disturb the tape much. But again, metal cutout, if you can probably see there, you've got on the right-hand side of the metal cutout, you've got a bolted connection, which then goes down and off with the cable. But you've then got the installation earthing conductor connecting in with the neutral. So what do we think that is? It's obviously TNCS. Could it possibly be another end of line?
Let's say, is it another end of line or three phase? Or
yeah, that's my guess would be, if there's a separate cable going with it. There's only two logical choices with it. It's either an end of line earth rod, or they've done a repair on a PILT cable that's gone all the way through from the joint into the installation. But that's also looks like it's an asbestos one as well. This might be oh no, actually no, sorry, no, that's not asbestos. My apologies. That's the old electricity board sticker on that. Oh blimey, don't see many of them around anymore. And then some funky seals. So what would we code that as? What's the tape about? It's falling off on tails. Is the blue cable actually white? No, it's just the way the tape's lying against it, but good spot. What do you think? TNCS conversion? Yeah, definitely. Something. Could have been TNS, could have been TT. So this is the trouble. We've got to, whether we like it or not, we're going to end up speaking to the DNOs more and more. The trouble is, I don't think the DNOs want to talk to us, because I think the DNOs are not resourced to talk to us. And this is the problem. And they will do everything they can, which is why they have those fob off sheets for electricians, to say, get the customer or get your electrician to do it.
I think fundamentally what's evident is they know that there are issues and they've prepared themselves and armed themselves with different strategies to get away with it as long as possible.
It's probably worth also mentioning that in their documents, it does state that the customer's electrician, if they go to someone registered with these organisations called the NIC, EIC or ECA, then they're happy. But what if they went with NAPIT or somebody else? Would they not be happy then? Is there a far-reaching effect here of if there's a logo on it, it's fine, we don't care, we don't mind? Or do NIC
you have to
produce a book?
You kind of have to ask. Yeah, you have to ask what kind of handshake has happened for them to say if this, this equals some level of acceptance.
Yeah, it's just a crock. It's 1970s. Make sure your name is in every single procurement manual and standard under the sun. It's just whatever badge you wear doesn't improve or enhance your competence. That's just
okay. So,
what do you think?
We have gone C2 here. We have got 58% have gone C2. 13 went C1.
Okay.
8 went C3.
Yeah, I don't think
23% went FI. I mean, that tape is the question. If that tape is obviously easy to remove, so it's not fixed or anything, and if you can then immediately touch live parts, I can see why C1s have come in here. But it might be in a locked enclosure.
So the last question, do we bomb the ladder?
Bomb the ladder?
Do we bomb the ladder that's virtually leaning up against the head? So this is where the problems lie, isn't it? I mean, you can see the single core cables where they're taped together with each phase. You've got then what looks like the double insulated cables going off to the main switchgear. Has that room been loved? Well, someone tried to tuck something behind there, but it's now used as a storeroom.
Yeah, I mean, these kind of locations should not be used to store things, especially things like ladders that are heavy and are easily, you put them and you spike the feet downward in that direction. That head is going to get knocked. So just for
the day, where is it? Somebody has said the black looks taped too. So those cables coming out of the head are taped.
Yeah,
so they are phase taped. Okay, red, yellow, blue, black.
You can see there's a bit of red peeking between the yellow tape.
Yeah, so somebody used one drum of red singles and just taped them up the phase colours. That used to be done a lot. Let's be perfectly frank. That's what people. That's why
it's easier to hold tape than extra drums, isn't it?
Of course it is. It's far easier.
Yeah.
Right. Next one. Ooh, this is a classic. This one.
Ooh.
So this is a looped service. This is where the service and a domestic incomer will come into a cutout. It will then supply you and your fuse. That connection will then be made to come back down via a cable, punch through and go into next door. It was basically a money-saving thing in decades gone by where they could save money on cable. It's a bit of a nuisance thing because if your next door neighbor goes down and you're looped off of it, you're at the behests of them. You also effectively have each house on the same potential zone, because a rising potential on next door will be a rising potential on yours. If they disconnect them, you potentially lose your earthing, depending on how the earthing is configured. But as you can see here, it's a right old, good old-fashioned mess. You've got an earthing conductor wrapped continuously around one clamp onto the other. So it's fairly evident that there's no real earth continuity on that cutout. The insulating compound on the cutout above is, well, evidently failing because there is pitch melting all over it. What advice would you give, or what would you do? What code would you place upon that? For me, it's a phone call, and I would definitely be doing a ZE. I'd be doing a ZE on that installation to start with straight away. To be perfect frank, I wouldn't be touching those clamps. But have you noticed as well, those clamps, they're not Tembi clamps. They're another different type of clamp. Because the DNOs did experiment with other clamps while they were walking away from BS951.
Yeah, that style of that coppery type is quite common around here. You see them all the time when it's not the 951 style.
All right.
So the one on the left has two connections on it. Does the one on the right have one connection or two, and the other one's under pitch?
I think it's just hidden under the pitch.
So right.
It's just two bits of bent copper or material with screws in the end, and it just clamps down either side. They're not very good. They're usually loose and dropping off.
So what do we think? Run the poll.
We have 58% have gone C2. Oh, 59. It's just tweaked. 57. Let's stop it now.
Let's C2 and FI. I think again, everyone hated me in the domestic for doing FIs. But when you're coming into DNO intakes, a lot of
There
it
are
is further
questions.
investigation.
Yeah, there are questions because we have to get more information on
And
this.
we will be hated for doing this webinar because we are talking about stuff that 1110 says is exempt. Yet the duty holder and the duty of care sits on who? Who is relying on this mess for the safety provision of the installation.
And again, subsequently, all you can do is use your engineering judgment to then, on behalf of the client or with the client, contact their authority. They may completely blank you off, but at least you've done your due diligence.
Daniel's done a good one. Could the pitch seat between the conductor and clamp result in increase? Yeah, I think it would.
That's what I was kind of thinking about when it's in there.
Yeah, definitely, especially when they're
especially as it starts to dry out.
Yeah, it will do.
It'll definitely decrease the resistance to some.
It is an amazing. We're lucky we've got some amazing pictures of some pitch leakage, because it is a phenomena that you do have to really start looking at a lot of things and getting the DNO involved. Because as you know, Dave, we've recently found a loose connection inside of a DNO head. I've found a number of loose connections on fuses and stuff using thermography as a tool. Even on the Fleur 1 Pro, do you remember I plugged it in and found it very quickly on a main fuse intake? So, well, we got, what has everyone said? C2.
Right. 57% have gone C2, 30% have gone FI, 13% went C1.
Uh-oh.
Daniel Casey
John's.
made a good point there about to actually call the DNO, the number is 105.
It is. I rang them the other day, 105, straight away.
Well, you don't have to look it up or anything. That's the number wherever you
105.
are.
In fact, put it all in your phones.
It'll magically route it to the correct place wherever you are. So,
yes, it will. And that isn't probably advertised enough, is it? That should the back of all the industry body magazines.
How many guys in the chat here have actually been involved with calling 105 or contacting the DNO and actually talking to them? Can you guys just put a Y for yes if you guys have, or an N if you haven't? Just wow, okay.
I mean, they obviously have other numbers, but it's obviously in the bad old days when you had to sort of look up the number for them, and then it was this particular one for a particular DNO and all that stuff is kind of gone now. So,
right, there's literally just a couple of no's. Everyone else is yes. So it seems weird that we don't have any kind of standardized approach to doing it. Everyone's kind of doing it on their own. Might be worth kind of either in the Discord or something, kind of combining our efforts to find the best way to behave and get what we need to from DNOs, because some of you guys might get blown off by them.
So here's an interesting one for you. So Regulation 110.2, the regulations do not apply to the following installations, and it's number 1. Systems for the distribution of electricity to the public. What's a system? How have they defined a system? Because for me, a system for the distribution of electricity to the public is the network, not the intake. Because that's the point of fusing, the point of demarcation. That's the point where it's everything that is relevant for your safety under this book is quite important. Just a different way of thinking about that clause, really. 110.2. It's always bugged me. That has always bugged me, that one clause, always. Anyway, let's go on to the next one. Beautifully orange painted PELC cable there with what looks like a variant on a 10B. You can see on the left there's a three-phase installation, three-phase meter. John's favourite person staring at us in stereo, which is very strange. That weird phenolic head again. Earth bar, so it's obviously a commercial installation. You've then got an insulated cutout, and a lot of these now Henley blocks are actually having labels put on them. Earthing terminal, and it says PME system.
PME system.
That's interesting. So if we look on the grey cable coming out here, it goes up into the neutral, but we also have an earth clamp.
Is this like a Frankenstein cutout or something? Or is this a common thing?
It's a common thing. And I was told by a jointer the reason why some of them leave them in is because depending on where it is in the network, that is left in situ to ensure there is no potential differences between the sheath of the cable, and the supply earthing system. So if you've got obviously that copper bar there at the top, sorry, the copper bar here, which is connected to the neutral and that cable sheath, there could potentially be a potential difference between the two.
So it's kind of,
that's why they link them.
So it's kind of reversing it. It's not taking the TNS separate from that. It's actually earthing the exposed conductive part of the supply sheet.
Effectively, yes. However, just to throw something more in there, if you have neutral currents, by doing that, you can create circulating currents on your network.
Yeah, that's not a good idea.
That can easily be solved by insulating that part of the cable.
So the problem is the supply cable has exposed metallic parts.
Effectively, yes.
So if they covered that up, that would get rid of that problem.
Well, if you think about what a PELC cable is constituted as, the supply conductors, the neutrals and the lives are very well insulated from the sheath. Now, when you take any conductor for earthing, you'll have a volt drop or an R2 value. And if you have two conductors at two different potentials and two different impedances, you can get a potential difference across the two. The only way of mitigating that is by linking them with a supplementary bond.
Which creates spinning circulating currents potentially.
And guess what, guys? This is also mentioned in the DNO documents. It's buried. Honestly, my head's been frazzled with this stuff over the last couple of months. So again, it's the configuration is almost in the competence of the jointer to a certain extent. Now, this is a perfect example to just talk to you about one little note. And if you don't mind, I'm just going to read it out. So there's a note in the UK Power Networks document, and it says replacing an older SNE network. So that is definitely an SNE network. It's an old PILC cable, separate neutral and earth, with a PME network, may lead to situations where customers would have an existing connection to a network earth terminal, which may no longer be appropriate on a PME network. Aha, doesn't that look like that? An earth terminal may not be appropriate on a PME network. Appropriate on a PME, in such cases, consideration should be given as to whether proceed with conversion and make alterations as are necessary to the installation of such affected customers, or to make the changes to the network in a manner which preserves the essential separate neutral and earth characteristics of the network and the supply connection. Simply providing a separate neutral earth connection to the combined neutral earth cable will not necessarily avoid the hazards of a PME network constructed using combined neutral and earth cables for these types of installation in the event there is a break in the neutral conductor upstream of the connection. Link them. Simple as that. Imagine if there is a loose connection in a joint further upstream on that neutral, the old PILC neutral. You're definitely then going to get a potential difference between the sheath and that earth bar.
Only because the sheath
two R2 values.
So it's the sheath that's the problem.
And so you leave them linked, which then drops the overall impedance, which is why there's even statements that state that if a cable is buried, you can consider that the old PILC cables as a longitudinal electrode, a horizontal electrode.
You're going to have circulating currents, aren't you?
Yeah, you will do.
Which is an EMI issue under 444.
Massively.
Yeah. Well, PME is an EMI issue on itself. It just is.
Yep.
It's absolutely terrible for that. So.
The networks are in a pretty bad state, to be perfectly frank. So what has everyone said on that one?
I actually haven't launched it yet. Hang on.
Oh, sorry, mate.
I was interested in listening to you talk on that one.
Sorry.
Terry Austin's put, is that a hole in the bottom of the head or a plug? It's actually a wooden plug, isn't it?
Wooden plug.
Yeah, just to stop the pitch falling out. So that's that one. And yes, neutral currents from imbalance or harmonics would now be shared on the neutral and the sheathing. Yes, they certainly will. So yeah, PME and TNCS in general is absolutely hideous for EMI. It's pretty much the worst possible choice you can actually have. So if EMI is an issue, you don't want TNCS in your building.
I think kind of the point of this being, though, as well, is it's not what we were taught. When I was taught, it was TNS, TNCS, or TT. Yeah. The earth rod's every 30 meters. No, bloody well is not every 30 meters. Even at the joints, they just put a coil of copper wire, put the joint on top of it, and that's it. And even there, they're not even driving the electrodes like they're supposed to be doing under their own standards. So it's not as great and as good as we all think it is. The fact of the matter is we're now entering that world where We can guarantee a live conductor into each installation, but we can't guarantee a neutral and earth connection. Now maybe people will start to realize why foundation electrodes are coming into the regs, because all that's happening is it's being kicked over the fence to the consumer and to the contractor.
Yeah, and
you put a foundation electrode in, you've got your own neutral earth reference point.
And fundamentally, if we do go down that avenue of foundation earth electrodes and then islanding, we are going to get rid of a lot of these problems.
Yeah, we will.
But electricians will have to engineer it.
We're going to have to learn it. We're going to have to learn and engineer it. Or wait for, yeah.
All right, 60% have voted. So let's go with it. We have got FI 70% and 23% went with C2.
Okay, so this was a video I was sent. We know this one. There's been a couple of these now where people have had gas services bonded locally into various electrodes and pits. I mean, that was done as just a bit of a lash up, let's be perfectly frank.
This is a main protected bonding conductor connecting to a gas pipe, but it's actually going out to an electrode.
It is indeed.
Okay.
Now, I have spoken to the DNO, and the DNO have admitted that they do this at times, is provide a local earth electrode, and it all depends on the gas network, the supply network, and where they are on branches and proximity to substations and all the rest of it. So if you find this stuff, yeah, there's a chance it may be someone who just doesn't understand earthing and bonding, or thinks that bonding needs to be earthed in that way. But there also a chance that someone from the DNO could have just turned up and lashed something in.
This kind of, if this is legit and not a bullseye, which I suspect it probably is, but if it's legit, there's lack of mechanical protection on that conductor out there anyway.
Yeah.
But if this is carried out, we should have a paragraph of information informing electricians of that deviation from the norm, so they don't scratch their heads looking at it going, oh, this looks like it's a cock up.
And believe it or not, in some of the network guidance, there is actually lots and lots of references to additional electrodes. There is reference to where PME is used not providing electrodes, allowing the person to provide their own. Oh mate, honestly, the amount of stuff in these PME guides. This is why we're going to do a part 2 on this. There is so much we've uncovered and read in the last few weeks alone. It'd just be impossible to cover all of this in this one webinar.
I've seen this kind of thing a few times, but only in like temporary systems for, where people aren't sure what to do. So they just spike in and they connect an earth. But I've never seen it on a gas pipeline.
Mark,
did you want me to do a poll for that or not?
Oh, sorry, mate. Let's just skip on for that one. That's just more talking point. Mark Holmes has said the Energy Network Association RA says the RA should be less than 20 ohms, which is really interesting because there's another document which has come from Ofgem, which says it shouldn't be 20 ohms, and says something about the. Do you know what? Can you guys talk amongst yourself while I get the actual phrase?
Mark,
it's quite
what
important.
RA is that? Is that any RA, or is it what specific RA is that referring to, Mark?
Jimmy, that's the underline.
Is this the underlined electrode it's referring to?
Okay, got it.
Okay.
So if it's higher than that, it's not actually going to do a whole lot. So
I'm going to say you wouldn't expect it to be that.
So this is the Ofgem.
Yes, right.
Just to let everybody know, Ofgem regulate the DNOs, and Ofgem on 13th of September 2013 have said there is a concern that by giving a fixed maximum earth electrode resistance value of 20 ohm, this is taken as the default value. The rise in potential is not calculated and proved to be safe. It is not clear that 20 ohms is an appropriate default value. It is therefore suggested it may be appropriate to leave the wording to sufficient to limit the rise of potential upon open circuit neutral conditions rather than suggest a value. And this was Ofgem's proposed changes to G12 submitted 13th of September 2013. So Mark, you're bang on right with the 20 ohms, but it's fairly evident that the industry regulator is telling them you might want to do a bit more or consider a bit more. And before you say anything, they've not done enough yet. But I think that makes it far more complex. I like the idea of having a fixed resistance. It allows me to at least do some form of calculations a little bit better. Excuse me.
Chris Ruddock said, wouldn't the reading be based on the maximum load? And yes, it absolutely would be, because if you've got a higher load, then the actual resistance needs to be a lot lower to have the same effect of reducing the voltage. So you can't really just say 20 ohms, because obviously it depends on whether you've got one little LED lamp turned on or it's like a sort of commercial installation, and there's like a load of, say, 600 amps going through there. So yeah, it depends entirely on the installation.
So just going back to Mark, this document, Google. Over the last 2 months, I have been Googling every day and going into the networks and all the rest of it, downloading this. And this document was a background of a change proposal. And as part of it, they actually requested, this is 2013, labeling of PME supplies. So after 2013 was when they introduced the labeling of, before then, there was no requirement to label as PME.
What's it called, dude? What should he Google?
Oh, blimey, sorry. So the document is called Ofgem's Distribution Code Engineering Recommendation G12/4 Requirements for the Application of PME, a review of engineering recommendation. Published 17th of January 2014, and it also references and makes recommendation to the working group known as the Wiring Regulations Committee, a number of changes. But there you go. So fascinating. Honestly, when you go down this rabbit hole, chaps, it's just wonderful. It's, well, not wonderful. It's a brain melt. But I think the term sow the seed, let it grow, consider, think, debate, talk, and then go from there. Right. Let's move on.
Yep. Okay.
Intake cupboard. This is a DNO installation, but would be now considered BNO, building network operator. Cutout is right at the bottom. And this is, well, I mean, it's just a fucking mess, isn't it, really? What would you code that? Look at it. Henley blocks hanging out the trunking. This has just been so badly altered and added to over the years. Probably meter operators maybe have done that. Maybe but you've got...
I'm assuming this is a location that is pretty much exclusive for them.
Yeah. Oh, it's in a lock room. It's in the lock room.
Because, you know, they clearly don't give a crap.
Well, you'd hope it was a locked room.
You would, wouldn't you?
Things like this in flats where the room is not locked and it's got push chairs and junk and all kinds of rubbish.
Yeah, you get like a landlord area.
Yeah.
Which actually doesn't lock, and then they end up putting their buggies and stuff and their bikes in there, don't they?
There's certainly a lot of junk in there. See, there's a
cable under a joint.
That's a multi-switch on the front corner of the picture there, not connected. That means probably someone's pulled it out the satellite system and it's broken.
Just to add to Mark while he's saying, a core cable under a joint will never be tested. There is currently talk amongst the HSE and the DNOs, because we are all taught that there should be an electrode at every single joint. What they're doing is putting coils of wire and calling it an electrode. Fine,
yeah,
but how that actually garners any real impedance sat underneath a torpedo joint is beyond me. So I think that issue is going to debate on and on and on. You can probably tell I have done lots of talking to the DNOs about this. Only because of I'm working on some DNO investigations at the moment for work.
Yeah, good point. It's likely public access due to key meters.
Is there key meters? Oh, good spot. Yeah, well, they have to go in there, won't they, to
Jesus wept.
Top up their extra 15 quid a week.
Wow. You could switch your neighbours off if they annoyed you.
Yeah.
Wow.
Turn
it
off
out loud.
Yeah.
That's a cluster of that's stupidity 101. That is absolutely insane. Normally an enclosure like this you would have, it would be, yeah, surely not. Surely you'd have like feeds, them isolators would feed like red head cutouts, and then there'd be a box local to the flat or something with their meter in. This would be a check meter, surely.
That's how it should be done.
There's definitely key meters there.
They have. They've gone in and changed the check meters for key meters.
Yeah, those square white ones on the sort of far left there, and the one in the sort of picture, those definitely key meters.
There's 5 in there, I think.
Can I give that a C1, please? Yes.
Yeah. I was on C2 until someone pointed out the key meters. I was like, oh, shit. Okay. And then
I was on C2 until... That's a good point. Key meters, man. The burden... Yeah.
That whole lot wants ripping out, and all the meters putting in the flats, and all the distribution cabling replaced up to there, and that's like 20 grand's worth of work there for somebody if they want to.
And the rest, I charge them 45 just for the fun of it.
Right, so we've got 73% have gone C2, 22% have gone C1. Except maybe some of those C2s didn't think about the key meters. Probably would have done what we did.
Yeah.
But yeah. No, me old man Daddy Watts. He'd be like C1, C1, C1. Yep, C1.
Okay, we'll move on. Interesting one.
Okay.
DNO supply, one of them black ones again.
That's not mine. One I found anyway.
Is that your one, John?
Yeah. Well, it's not one I fitted, obviously, but it's one I've stumbled across in the daily rummaging.
Go for it then. Go on, talk us through it.
That is a smart meter, and it's notable how big some of these smart meters actually are. They're actually bigger than the old mechanical ones that they've now replaced, which is partly why they've done this thing where you're supposed to put it in a specific place.
Yeah.
So we've got 16mm tails there, and they go down in there, and they go inside the cavity wall, and then the consumer unit is on the other side of the wall as built. It's actually quite common arrangement. And the problem here is you can look at what's in the cavity now, because of course originally the cavity was empty when it was constructed sort of 30 years ago, and subsequently somebody has come along and injected those insulation beads into the wall cavity.
Yeah, those new innovations to lower our energy losses and potentially set fire to every building.
Yeah, and how many pictures do we have on our Instagram page alone of boards that are filled with those beads? It's mind-blowing.
Yeah.
Are they single insulated cables, John?
No, they are the insulated and sheathed type. So.
Okay.
But yeah, they're 16, which is obviously a bit on the small side. But
it's an interesting earthing configuration, because the side of the cutout you can see is insulated.
Yeah.
Where we had a block exposed, they've obviously changed it over time, and that's insulated. But you've got two earthing connections.
There's two conductors there.
Mm. So it's evidently PME. It's on the red phase, so it's obviously a PME on a new estate, telling somebody it's on the red phase, which is what they used to do. But maybe that's a local electrode. Maybe that's the end of line.
Is this another end of line one?
No, it isn't actually. It's
not.
What that is the thin one is the earth to the consumer unit, and then the bigger one is to the gas meter, which is fairly adjacent as well. So.
Oh, there you go. Okay.
Again, it's an older one that had a 6mm when it was fitted, which was compliant.
I just stuffed it in there.
Do those two conductors fit nicely in that terminal?
I didn't look. Probably not, particularly because they're different sizes. So there's going to be.
I'm gonna say, I can imagine there's a couple of strand clippings maybe there.
Yeah.
Yeah, that's probably Well, hey, who's ever heard of reduction lugs? Haircut. Yeah. No main earth terminal as well. Yeah, I would suggest there needs to be an insulated Henley there. I would probably ditch that and put that into a Henley and then take that one. Yeah, that's just. Yeah,
I would then, and I'd label the gas and the earth separately.
So, did you see one, John?
C1? No, that wasn't a C1. That was an FI, I think. Came on that one. So maybe.
Okay. Does everyone agree?
We have got C2, 56%. And I guess this is on the assumption of the loading. And the risk of the derating factors of the insulating material, I expect. We've got 6% C1, 14% C3, 25% FI, which is what you did, John.
Yep.
See, I'm sitting on a C3.
Is the FI, John, because you want to then observe the demand?
Yeah, I mean, it's only a fairly small house and all the heating was gas, so the actual the total load isn't likely to be particularly excessive. But the other unknowns here is what rating is the fuse in that cutout. Because, say, 16 mils.
So you got 16 mils there, so you may not have
a 60 or amp fuse or something. Well, doesn't actually matter, but there's quite a lot of sort of unknowns here. And then there's obviously the cables up in the cavity, which may or may not be damaged, overheating. Who knows?
So in this case, if I can't see the fuse, is that an FI or is that an operational limb?
Could be either. Limitations.
Because an FI would be unsatisfactory.
Yeah, limitations generally, because in most cases you can't, unless you're going to hook the seals off, you're not going to see the fuse rating. So most of these, certainly domestic ones, go down. There's a limitation for the fuse. Cool. Mainly because what else are you going to do?
Exactly. Okie dokie.
As everyone said, C2, C3. I'm C3, by the way. I'm going to argue with John and say it just requires improvement.
Just requires improvement. I would carefully observe the utilization. John said that there's no electric heating. It's not a large house. I should imagine subsequently till the next periodic inspection and testing, there's probably little to no cause for concern. So I might be okay with the C3.
Yeah, I'm never having a smart meter in my home.
It really depends on that. It would be a C3 to a C2 on that, which you could basically mean could be an FI because I want to look at the use of the system.
Fair enough. I'd have a smart fuse board. I'd have a smart boiler, but I wouldn't have a smart meter in my home. Next.
Radio.
Right, this one. This was in a flat that I lived in for about 3 years, and this was on the ground floor, and the flat was like on the second floor. So this is the cutout, the meter, and the connection via that thing in the middle, which went upstairs 2 floors to the ancient Wilex fuse box that was in the flat. And it's another one of these 40 amp meters, which obviously isn't particularly adequate for much these days. So,
In fairness, John, you could have done a better job clipping the pyro, couldn't you?
and we've got our lovely 951 clamp on the.
A 951 clamp, yeah.
It was allowed. It was fine at the time. Leave it alone.
Well, that meter is 1968, so yes, it definitely would be.
Is that, I can't see, is that a fuse? No, it's not, is it? No, it's not a fuse.
No,
it's
it's
just a
just
neutral connection.
yeah,
It's the neutral connection.
So we've got what looks like a TNS supply with a couple of bits of green and yellow. Evidently an electrician has installed that because...
Am I right in that the green has just gone behind the board and coming back through the board?
Yes, that's
Because
it.
it's just right. It's just
somebody
disappeared
tried
from
to
me.
be smart. Okay.
Someone's been clever. And
Why they did it, I don't know. It's only like 2 inches below.
I was
that.
going to say it's just like it's just there.
Yeah, it goes in that hole and then comes out underneath and goes into the
But
clamp.
here's the point: now it's disappeared from inspection view. Do you now have to test it for continuity?
Hmm.
And
You know?
there's actually on that bottom bit, there's actually 2 clamps on the outer of the cable there, because there's the one at the solid green, which is like a copper one underneath, and then you've got the 951, which has been put in sort of partially over the top with that.
Oh yeah. You can see there is
Additional
2 different. There is 2 different types of clamp on that.
And so, what's that other green and yellow doing? Is that a local bond?
I can't remember. I don't think so, because all the services were upstairs, and the gas meter was upstairs as well.
Wait a minute. John Ward lived here.
Yeah.
Did you do that?
No, I didn't do.
Oh, we nearly had him, folks. We nearly had some lash ups with John Ward's name on it.
This was a rented flat where the landlord was absolutely useless and never did any inspections or any work on it whatsoever.
He didn't need to. He had a bloody electrician living in his flat. Go on, John. You can do that. Right. So what's everyone coding this then?
We've got C2s
I do
building
love
up
pyro.
on this one. Is this in a enclosed area, cupboard, or what? Where was this?
No, this was literally by the front door on the ground level. So you open the front door, and this was basically under the stairs, just behind it. So no cupboard, completely accessible to anybody. Open the front door, and
Okay.
if you
See,
put
this,
your
I'm
stuff in
thinking.
there, it could bash into it and break bits. And
I'm thinking C3 here, but the pyro and the fragility of it, and children and all the rest of it, I'd probably C2 it just based on that pyro.
I'm on the same ballpark. I'm looking at
Head.
that pot. I'm looking at the
Yeah, the
cables
pot.
coming out. I'm thinking a bang or two on that. I don't.
Have a 40 amp for antimeter as well.
Yeah. Okay.
Southern Electricity Board. Yeah, they don't make meters like the Eastern one did.
We've gone 50% C2, 31% have gone C3, and 16 have gone FI.
yeah, I think that's pretty fair. So
Yeah.
the whole.
I'm
flat
I'm on a C3, C2, but then when I hear about the the accessibility to the public and that pot, and it is fragile, as Paul said, a couple of whacks on that pushed me over C2 into C2.
Yeah, so
Well,
it was
this is it.
completely accessible because the flat was above some shops, and this was basically on the ground floor. So there was a door which went straight out into the street. You open the door, this is inside, and there's just a set of stairs go up to the flat, and where there's another door which goes into the flat, and that's where the fuse box was. So.
Yeah. Daniel says, I'm not a fan of that pot, literally just a bit of putty and a crimped cap. Technically, he's correct. It's just, that's all it is.
So here's one for you, gents. I'm going to throw something at you. According to the cutout guidance note for EV installers, that cutout is a black plastic, circa 1960 to 1990s. If an installer is presented with this type of cutout, they must assume the fuse size is 60 amps. If the installation designer's calculations confirm the installation total will not exceed 60 amp, there is no need for a DNO assessment, and the EV install can proceed as appropriate.
So do you think
Interesting.
electricians are being asked on EICRs to assess the condition, do you think they need access to that kind of information where they've got
Yeah. So what we'll do at the end
illustrations
of
of
this,
different cutouts and what we should assume of them
yeah,
from certain guides?
Dave, what we'll do at the end of this is I'll quickly close this and I'll share the document on my screen that I've got with the guides to cutouts so that people can download it, they can print it off, and it goes through every type of cutout available, including maybe some ones that John Ward may have.
Because that's the thing. I mean, you know, we go, what view should that be? Oh, it should be. But if we've got a standard that goes, this should have this, then we can go with that information.
Funnily enough, I'm looking at. They didn't even take your copyright off the photo, John.
No, they just blatantly.
Right, we'll definitely show that one then. Right, okay. So we've got a gift for you at the end of this. Right. So what's everyone said on the scoring?
All right. This was C2. 50,
yeah, I think some common sense.
C3 31, 16% was FI. Pretty much in the same area.
Probably still there. This was 15 years ago. This was taken, so who knows?
Oh, what's this
installation?
One?
Yeah, this
identifying the supply type. This is a GRP cutout. It is a brand new concentric cable, 3-phase isolator. Can anybody see any issues with it other than obviously the supply type? Is there anything else you can spot? This is a good
using
spot.
Two phases.
Yeah, look carefully at what's actually connected to what here, because it's not what you might assume it is straight away.
Damn you, John. Right, go on, John. You can.
But nothing. One phase coming out.
John,
go on, John.
Yes, this might look like a 3-phase supply, and it is a 3-phase cut out there on the cable, which goes back to another thing which isn't in this picture. But 3-phase meter. Notice there's only 2 of the phases connected. The middle one doesn't have any wiring attached. So we've got 2 phases coming out, going into that meter. And then to go into the isolator, see there's only the 2 left phases connected, and the neutral, obviously. And then on the top of it, despite it being a 3-phase supply, allegedly we're only actually connecting a single phase to the distribution board, which is on the right to the picture. So this is actually a 2-phase supply, and the reason it's a 2-phase supply is because the supply from the street is defective, and this was only discovered after the building had been mostly constructed and the cables had been installed under the ground and all the rest of it. So what the DNO has actually done is where it comes into the main distribution cupboard, which is one of those things with the J-type fuses in it, they've basically linked the red phase that comes into 2 of those and the blue phase to the remaining one, and there is no yellow phase on the old colours. It just doesn't exist. So it was all set up for 3-phase when it was built, but they've got basically 2 phases to use, and that's your lot. And because of this, which isn't in this picture, the lift in this block of flats is a 3-phase lift, and it actually runs off of a phase converter connected to one of the phases because they haven't got 3 phases available. So there's a dog's dinner for you.
Mind blown.
And the phase converter in the lift is very interesting because trying to run a 3-phase lift, and it's about a 16 or 17 kilowatt lift running off of a phase converter. So you can just imagine the starting current off of the single phase when that thing switches in. It's somewhere, I think the peak current is something about 120 amps when the lift actually starts. And this is on a 100 amp supply. So yes, it's a complete and utter disaster.
It's a mess.
And they had a quote from the DNO to fix this problem. They said that if you wanted the 3-phase from the street, that'd involve digging up most of the street for several hundred meters to replace all the cabling, and the figures were sort of 5 digits plus.
And they're suggesting that was the client's expense, not their own.
And then there was another quote got where they could bring a supply in from the road over the other side, which would involve going across someone else's property, and that came out about a similar figure. Sort of 20,000-30,000 quid was figures that were thrown about.
Cheap.
So needless to say, it wasn't done, and it's now 2 phases. And unfortunately, the flats that are on the same phase as the lift, the lights go quite dim when the lift starts. So
no surprise.
No surprise there. And there's, I think it's 11 flats in this building, and they've got basically 2 of the 3 phases kind of distributed between them in a not very even fashion.
Bit of a mess.
And it's PME as well.
Yeah, I was going to say, first question is what supply type is it? It's PME, and God forgive whoever used that insulating tape around that cable. They just sickens me to my stomach, that. Earth bar looks like it's seen better days as well. It looks a bit rusty and corroded. But I think one of the lessons learned here, John, as well, is I mean, in recent times, I've gone into three-phase installations, looked at the head and assumed it was three-phase, and then looked closer and then gone, hang on a minute, what they've done is they've swapped the cables out of the meter into different terminals on the top of the fuses and doubled up on some of the fuses because they had a network problem. And I have seen installations for years that there was a fault on the cable in the street. They've gone into the connected load building. They've swapped, say, the yellow phase onto the blue phase, doubled up them terminals, fixed the repair in the road, couldn't get back in and have left it. So it's another thing we need to consider when working on three-phase DNO heads. It's not just a simple issue anymore. And I think that's one of the reasons why we're covering this, is those who think it is, I would respectfully very much disagree.
So do you want me to run a poll on this?
And
if you do we take the information John's given us, or just
go on then, run a poll,
or with what we see only?
No, just, you know what, run this one a poll based on what I'd be interested to see what people think.
Bear in mind, I mean, John did say that the lights are flickering and stuff when the lift is in use and things.
Yeah, John Ward, by the way, he's coded that as run. He invented a new coding system for it.
Yeah, the lift, unfortunately, is one of these hydraulic jobs, which means when it goes up, all the weight of the lift is on the hydraulic thing, but when it comes down, there's pretty much no load at all because it's just under gravity. So not a particularly good thing, but it appears that whoever built the place assumed that three-phase was available, all the three-phase put in, and then it was only discovered when it was making the final connection in the street that, oh, actually, no, there's only two phases here. So,
wow.
So it's been lashed together with a phase converter.
I don't know why the network operators were not held accountable by somebody, probably because the owner of the building didn't have the intelligence or the time to actually confront them.
Well, there's a bit more to the story, because the owners of the building didn't finish it. They actually went out of business before they managed to complete the building. So someone else was called in to finish the building, and they did it as quickly and cheaply as possible because they weren't getting any money out of it. And then shortly after that, they went out of business as well. So lots of stuff in this building is kind of sort of lashed together, thrown in at the last minute, and not really done to how
so the moral of the story is lash it in and go out of business.
Sounds like the DNO got away with it.
Looks like it.
Yeah. Okay, so we have got a 44% C2, a 25% C3, 28% FI. So that's interesting.
Good poll.
It's a good spread. It's again, when you're talking about the use of a system, if you've got people in the home and the lights aren't, reliable, then I can see how you can easily C3 that or FI that. C2, if that lighting does create, if the absence of, or is it just lighting that's affected?
It's basically lighting. It's just if the lights are on in the flat, they know when the lift is used because it dips for a minute and then goes back. So it's not.
What you're recommending, John, is don't go there for Christmas Day.
That's right.
Yeah.
Oh my.
Fortunately, it is gas heating in the flats, but even so, it's a pretty much of a disaster because it was designed for a three-phase distributed amongst 11 flats. And
funny enough, I think, Dave, we're going to maybe cover gas heating systems in the next webinar in some form or another. Little clue there.
Maybe.
Right, here's one of my personal collection. This is my favourite DNO intake of all time because
is that as close as you could get to it?
Yes.
Right. Okay.
It was a DNO where basically it was a refurbishment of a London Underground station, and a brand new panel was put in front of the old DNO intake. And I just thought, well, that's great, because the DNO came to disconnect this and couldn't find it for all the tea in China, and it bugged the hell out of me. And I found it, and then later on I found the meter and all the tails strewn across a storage area, and that bad boy just left in that condition. The lesson learned from this photo, and I wanted to show it here because it's a great one, is always look behind massive panels. You never know when you're going to find a DNO head somewhere. I wouldn't code it because obviously, as you can see, it was redundant and all sealed up and stuff like that. But it's just one of them weird stories I thought I'd just throw in as a have a look. It's just mad. Just I've got pictures of fuse boards that are literally hanging onto cable ties and
is it energized?
Sorts of that supply is, yeah, the intake is, but there's obviously nothing connected to it anymore. And there was a new power supply going, a new panel, and they just pushed the panel up against the DNO head. It's insane what some projects do. Major projects we're talking about, idiots. But yeah, just if anybody's ever looking for a DNO head, sometimes on commercial industrial, think outside the box, look behind the panels. You never know. We're not going to code this. We're going to move on because this is a story. Now, this is a good one. This is a lighting feeder pillar, including spiders. Kind of tried to dramatic. I hate these new cameras with the 4 thingies because they're, I don't know if you've noticed, but photos are getting skinnier and longer. So if you're ever going to send us photos, please tilt them horizontally like you would on TV. So you've got a supply there. Some concentric cores coming out to an earth terminal. Yeah, so if you were new to the lighting industry and you were going out and looking at some of these feeder pillars, what supply would you assign to that? And would, if any, would you code that? Ignore the spiders. Let's just have a look in the chat. That is an absolute. Oh, is he talking about this one? Volt drop and additional cast. TNS.
TNS.
TNS. Let's have a look at my.
Did you want to run a poll on this one, or just?
I'm more interested to see what the comments are. Just if there people can let us know in the comments, I'll skim through my little document of doom. While if I had a little bit more time, it would have been included, but then it would be about 10 hours long. See if there's anything like this. Lo and behold, there isn't.
Yeah, the question here is whether that's concentric cable or split concentric cable.
How can we tell?
Well, without ripping it open.
That's the thing. These concentric cables can trick us up, can't they?
There is, fun enough, there is guidance now on what constitutes them. Again, available for the DNO. I have never been so blown away as to how much information is provided by the DNO. It's incredible.
To be fair, mate, it's we have this discussion regularly about why don't the standards free? Why aren't the standards free? Why aren't they available? And we go, well, they are in Dubai, they are over here, they are over there. So it shouldn't be surprising that another area of industry such as DNO does completely the opposite to what we do and makes them free. It shouldn't be a surprise.
Very true. I think there is debates at the moment going on about whether standards should be free or not. I think there is a public duty of care being breached by not making them free. Yeah, personally, it's the one thing that I would happily go to prison over, because to me, I think it's completely unethical to sit millions of pounds worth of safety standards behind a paywall. I think it's a national disgrace.
If they are made free, we'll have to immediately do a crowdfunder and raise some money for Dave Betteridge, apparently, because he spent a fortune on his.
Oh, sorry, Dave. Yeah, I know what you mean. Well, yeah, if I didn't have a BSI Online account, luckily my company paid for, because I got IHS as well, which gives you. So this is really sad. Today, I actually got a copy of the New Zealand wine regulations, and the one thing I loved was the committee that wrote the New Zealand wine regulations are all trade electrician associations. There's virtually no manufacturers on it, so I'm looking forward to reading that one.
All right, Paul's got to fly. See you, Paul. Not you, Paul. Other Paul.
Paul. Okay.
Paul Buriton's got to go.
Right. So this is actually a PME.
PME.
Yeah, it's PME.
And how did you get that from that?
The chap who sent it to me told me. So he sent it to me on Instagram. This is a PME supply for a lighting column feeder, and at the end of the lighting column circuit, they have a separate earth electrode. It's not the way it should be done. Basically, what they've done is they've taken the armouring there, they've separated it, bent it down, and put it into an earth terminal. Yep. What they should have done is actually put the earth connection directly into that neutral there.
That would have been a lot more easier to identify then, wouldn't it?
Yes. This is the problem. Configuration is in the eye and the competence of the jointer or the person putting the cutout, and they're all different. And this is one of the problems, really. So what would we code that? The fact of the matter is that's exposed. That all of that is
Right.
a technically neutral conductor.
All right. So now we know that. Do you want me to run the poll?
Yes, please.
Okay. All right. So it's exposed live conductors.
Why don't they ever label or ID anything? As I said, it's only since 2013 that they've been told to. But Ofgem are the regulator, and they care more about unit rates of energy than what the DNOs do. Do you know, if anyone watches this from the DNOs, they're going to go ape. Thinking like, how dare they? How dare they? How dare they criticise us? Yeah, and we're entitled to our engineering views. What have we got on the poll?
All right, we've got. Let me get 70%. There you go. 70% have voted. We've got 61% went with C1. 32% went with C2. So, what's your thoughts on this, then?
Finishing as a C1. Yeah.
Is this enclosed? What am I looking at here?
It's basically a lighting feeder pillar, but it's a concrete one. There are some concrete ones out, not metal ones. Now, the reason being is why? Because if you look at a lot of the PME guidance, it states do not use metal feeder pillars. So a lot of them are brick or GRP now. A lot of the modern ones are GRP. If you have a metal feeder pillar and it's a PME supply, you should be putting a local electrode near to it.
It's a big exposed conductive part, isn't it?
Well, it's been banned on railways. PME has been banned and metal boxes have been banned since 2011. We know that this knowledge of PME risk is probably at least 20 years old.
It's everywhere but in our industry.
Everywhere but our book.
Yeah. Which is
fair to say.
Crazy.
Fair to say. I don't think it will be for much longer. No. I think it will be in our book eventually. So there you go. This was actually what happened after. Oh, hang on.
Oh, you've got the
after.
Okay, stop sharing.
There you go. That was what happened afterwards. Left the bunch of lazy bastards. But they did exactly what they should do. Changed it. Put a proper cutout in. Insulated. This is one of the good ones that I've got a before and after of. I was desperately trying to find more of, but yeah, so that was the after of reporting it to the DNO and them coming out and someone competent going, yes, that should be enclosed within an insulated cutout, a GRP one. They're not plastic, they're GRP. So yeah, I thought that was a great example of an after. This is an interesting one. I don't know why there are two pictures. So it's probably me screwing up here, but let's just look at the picture on the right. Well, actually, no, do you know what? We can look at both, actually. Obviously, a really dodgy supply where someone has drilled holes to access the screw terminals. So that evidently isn't an authorized DNO cutout. But more importantly, the one on the right, that's inside one of those black cutouts with a PME link. So that's actually the link that you can connect or disconnect to make it either a TNS or a PME. So it's one of them rare insights that you can see. Now that's obviously you can see on the bottom. Let's just concentrate. We're not going to code both of them.
Yep.
One on the right. So you can see there's those weird clamp things on, again, what look like an armored. They've then obviously double insulated, split out the line and neutral conductors, and then just linked across to the earth terminal on that block. So, and that block has obviously an exposed. These will be quite familiar to a lot of people. I think it's fair to say there's a good few million of these. Where
so with this lid on to the electrician,
yes.
This looks like a TNS.
Yes.
Because you've got that braid there. But when you take it off, you can see there's that link. So it's a PME.
Mm-hmm. And I worked on a lot of these for many, many, many years. Mm-hmm. And these used to confuse the hell out of me until somebody I went on the training and somebody said that cutout can be used for TNS, but it can also be used for PME. It all depends on if they have a separate earth cable that comes up on the right, which as you can see, they did. Look, you can see from, am I pointing at it on my screen? You can see here the green coming off the armor, coils round in a helix, goes up into the earthing stud, for the earth connection. So naturally, you could assume it's still a TNS with just a facility of an earth terminal built in. But that link now makes it a PME. This is another reason why it's so important to engage with the DNO. The biggest problem is, and everyone watching this, is the DNOs are just awful. They're terrible.
In the comments, it's not the holes are not drilled in. Apparently, there's a bung or plastic cover that goes over those. That's a cloverleaf shaped hole.
You're joking.
Apparently.
Really?
That's what several people have said there. So.
Oh my God! Well, that's definitely, there can't be a DNO one because it's not in any of their manuals anywhere. That would be, yeah, okay. That's definitely not a DNO cutout. I can't see that being an approved method of connection, or. But it was one that got sent into us, and I just thought it was just mind blowing because I've never seen one in 20 odd years of looking at this and studying this, and this is in none of the manuals whatsoever. Trust me, I've got them all sitting on the floor.
I've seen cutouts with a bung on them, but I've never removed it to see underneath them, so I guess that's what that is.
Yeah, interesting. But yeah, that one on the right I think is the main one for me that's quite important, is that connection there. There are millions of these. I've worked on so many installations where I've connected into that terminal, not realizing or not thinking that there could easily be a link inside. I don't know.
See, to me, I've always defaulted that they are PME because they're next to the neutral. They're on there with the neutral.
But I've seen, Dave, separate earth wires that have come in literally separately all the way along and into that side connection. I've also seen inside these when I was working on them, because I have worked on them when I've done like new meter connections and renewed all the tails and stuff, where that link isn't in. And that's the fascinating part about these intakes and this whole DNO mystery, is how much do we actually know about the supply configuration that's coming in? Because the theory of what we should see.
Let's say that I've got that the cover's on and the link is out. I could do testing. I can do a continuity testing between the neutral incomer.
Yeah, you can.
Isolated and the earth. If I have continuity, then I have my PME. If I don't, then I do. Yeah, and I have TNS. So just an extra step. That would be an FI in that case.
Oh, Dave, that could be in a webinar called "The Hidden Test" that BS7671 doesn't tell us to do.
Another one, yeah.
Can we go back to that previous lighting pillar? Because apparently that's
which one, mate? Sorry,
cut out in there. Yeah, that's the same one with the black cover on it.
Yeah.
Oh.
So it's the same picture. It's the same cutout style. That's got the cover in and the.
I thought that was a bug.
So apparently that's the plug that should.
Is that genuinely an actual cutout? Oh, mother of God!
I used to call it a butt plug or something when I was on the tools. Call it a plug.
I've never seen that cutout, and I've seen virtually every single type. I've never seen that one before. So this is great because I'm learning something on this webinar, which is awesome. Okay, well, if that's a DNO cutout, I would like to meet the drug addict who designed that. That's definitely a weird one.
It is crazy.
I can see why they've designed it. It's minimal access to live conductors. I get it, totally get it. But, you know, the old cutouts were far better at actually minimizing access. And so I don't know why they keep redesigning these cutouts, to be perfectly frank.
Yeah, it's a Lucy one, apparently, according to Daniel Casey. There's a link.
Dave, did you just say butt plug?
Yeah.
Okay. That ain't pitch that's melting. That's oh dear. Dave lowering the tone. Right, next one. Did we code that, by the way? Did everyone code that?
No.
I don't think we will. It's a talk, it's a debate piece. Let's not code that one. That's just did you know? These are kind of the insights into DNOs that we may not be aware of. Here's another one. It's quite an interesting one, actually, to be honest with you. It's again, this is my apologies. I ended up chucking a load of photos in slides, so this may not make any sense now because I had like 100 slides and I had to just go mad redacting this. 100 amp fuse, earthing terminal, PME, quite a large, hefty, chunky 35 mil going in. He is a big boy, isn't he? The Earth's bigger than the bloody neutral, pretty much. Yeah, it is. Going into an isolator. Is that holes drilled on the side there off the cutout? On
that
the
looks like
Series
that's
7?
been chewed on.
Like hole. Yeah, they're not very regular, are they? So they might be holes in that case. But
somebody's attempted to drill holes in there. Would you code that piece of equipment. On the right-hand side, by the way, everyone's wondering, that's just another lighting feeder pillar. Single core conductors coming out of the cutout, and the volt stick to just prove that they're obviously still energized. But let's stick with one on the left because it's DNO intakes we're coding. Would you code that?
It looks, so it's a PME. It looks like someone's maybe tried to see if there's connections on the right by drilling holes to see if there's bloody terminals there.
Yeah.
And then having figured out there aren't, they've taken it off and then put it next to the neutral.
Or yeah, they've just cut it off and realised it slots out, unplug the fuse and slide it out.
Because these, you can, isn't it? You just slightly pull the fuse. There's no seal on it, and then you can just you can pop it off, can't you?
Ventilation. The comments are now going downhill. By the way, they're talking about butt plugs and gimp suits. So if you're watching this on YouTube, there is some hilarity on the comments that you're not going to see, thankfully. There's the old MEM 100 amp isolators. They were a miracle when they came out. They were electrician's best friend. You couldn't get them quick enough. No, anyone who worked in electricity boards, if you got any of them isolators, they were flying off the shelves. Would you code the intake? I would. To be honest, I'd C3 that.
Yeah, and the holes are obviously not supposed to be there, so they certainly would require a replacement. So.
Run a poll, see what everyone thinks.
All right, run a poll. Right, so this is for the left image, yeah?
Yeah.
Okay.
Dave Fault, I wonder if the DNO specified that 16 mil earth. Yes, they have. If you're talking about the main earth connection, yes. Minimum. It's always minimum. But yeah, I'm gonna see through it because I can't see any shiny copper parts. I can't really stick my finger in it.
No, it looks to me like there's nothing there, and that's what
they've done. Literally a 3 or 4 mil hole.
I probably see 3 as well.
I love that big main earth, beautiful and big. Absolutely. In fairness, on my old house, I think my earthing conductor on my TNS supply is 35 mil. Oh, I know, it's terrible, isn't it? It's just awful.
All right, yep, 77% voted, so we'll end on that one. And we've got 80% have gone C3. 11% went C2.
Yeah.
2 people went F5 and 1 person went C1.
Okay.
Yeah, there's nothing sort of immediately dangerous there. There's not sort of live bits exposed, so C3.
Most likely they just click the C1 to make the thing disappear from their screen.
And this is the luckily we're coming towards the end. So don't go yet because you're going to miss the really controversial bit.
Is there an end? Yes, there is controversy.
There is an end. There is an end. So this is the last of the coding slides.
Okay.
You've got a brand new Lucy cutout. So those cutouts have at least 200 to 400 amp supply fuses in them. But we have this lovely, beautifully shite lash up on the. That's the only words I can use because you've got, look at it, you've got a three-phase supply coming out here with the red single cores. That's old DNO supply that they've reconnected back into a new intake. From the new intake, they then bought a larger single core into what looks like small torpedo joints, and then have probably just through jointed that onto something that goes into what looks like some sort of weird ducting and off and away. And then obviously you've then got the PME, you've got a PME terminal on the right here. You've then got a separate conductor here. And then you've also got another terminal here. It's a bit of a mess.
That is shit. That's for sure.
Shit, isn't it? It's just shit. Absolutely no. Whoever did that, honestly, no frigging pride whatsoever.
We need a JS code introduced.
JS.
Just shit.
We will put it in part 2. We will do a part 2 on this, and we'll have a JS code. C3 can do one, and we'll put JS in. I think. Again, this is all our opinion, everybody. So please don't hate us on YouTube.
All right, let's lodge a poll and see.
What do we think it is supply-wise? Because normally on these sorts of things, you do see earths coming in from the joints, but I'm naturally assuming that cable there is coming up underneath, going into the joint, but then again, you've got earth conductors going round. So there you go. You can see that conductor there goes around the bottom and up into that insulated earth terminal there, probably to facilitate these. You then got this as a separate conductor coming in and coming off. Then we've got
So that one,
this way.
that one bends and goes up with the header, doesn't it? The bigger
Mm.
one. That one.
Yeah. Is it TNS? Is it PME? It's been recently done. And considering that they're supposed to be labeling this up, but you and I both know, Dave, the DNOs to this day, their operatives, if they're changing something in the street, they still don't go in and change the supply intake.
No.
We'll cover that on part 2. Part 2 will have a very specific reason and dynamic around it. Because I think we will do it, because we've got some great installation pictures which we can put in as far as this is and it's actually not. But yeah, what do we think? What does everyone think? Coding wise and supply type wise?
Okay,
Yeah, I noticed that green and yellow tape on the wires in the trunking. That's from a council block of flats. Absolutely.
Yeah, and was the old intake buried in the wall at the bottom of the grey duct and trunking? Well, fairly likely, yeah. It was probably higher up, and it may well have just joined straight onto the bottom of it there where the gap is.
Mm.
And they fitted that, so it's a new piece of chipboard or whatever behind there. So they've just sort of bridged over the hole and put the new one on the front.
Yeah. So it looks to me like that larger earth cable is going up into the header with it, isn't it? So
Yes.
I mean, we can't see underneath that.
No.
So it's coming off,
Oh,
it's
God.
going around, it's bolted on the side. So, and that cable's going to be too large to be wetted on or anything. So it's wetted on. So
this kind of one of the things, this is kind of my gripe for the session. If you are going to send photos or take photos for people to code, try and get some close-ups, but also try and step back as far as you can so that we can ascertain horizontally the layout, the configuration, where it's coming through the floor, the whole routes of the cables. I get sent loads and loads and loads of pictures and I can't use them because there's just not enough in there to actually tell me.
This larger earth cable, I want to see underneath that header to actually see if it's
Yeah, I know.
sweated on or if it's just disappearing.
No, I think I would more than likely assume that goes into a duct with that supply cable. But then again,
So
that cable there
that's likely
looks like
to be
it's connected to that cable.
Yeah.
So that could be a bonding conductor for all we know. That could be a gap water bonding. What do we think the supply head is? Because if you look at the wiring regulations, we should be able to easily ascertain the DNO connections.
If you ask me to code right now, I'll be FI because I want to look further to find out the earthing system. I can't.
I'm with you totally on this, Dave. This is an FI period.
On that one,
in my view, yes, there's some lash ups with the cables and the trunking.
Yeah, the cables, trunkings, and stuff. That's a separate observation. Those are C2s.
Yeah.
But there's an FI with regards to identifying the earthing system on this one.
Yeah.
For me.
And the joints are a JS code. I think we're all agreed it's just shit.
Just shit code.
And if that's an approved DNO method, then the DNO seriously need to really consider what approved is, because that's just pants.
The thing is, I mean, so this is just, I mean, do you know the background to this? This is just a new supply refeeding old mains.
There's a new supply that came in and I got sent it on a message saying, this is for you, this would be an interesting one for your webinar. Okay.
But, I mean, those cables could have easily been terminated into something a lot more suitable than that.
There you go. Matt Hailstone. I'll try and get a better photo next time he's there next week. There you go. Matt.
Awesome.
If you can, we'll include this again next week on the webinar again, so we can talk about this, because this is a cracking one. But yeah, if you can get more photos, yeah, definitely. But the thing is, you imagine being a Sparks walking in on that by yourself on your Jack Jones. Please get the keys, open the door, you look in, and you just go.
Well, that's one of those moments where you open the door, you go, oh, for fuck's sake.
No,
it's just one of those moments.
Why me? Why me? What the hell is this mess? How do I report this? I wanted to get home early today. This ain't happening.
Just pretend it was locked.
What's everyone coding that as then? Because
we've gone C2 50%.
What's the rest? FIs.
FI is 30%. I'm with FIs on identifying the earthing system. Yeah. C3s are 10%, 10% C1s. So
I'm going to go with either C2 or FI. I think would be really good.
Mm-hmm.
C3, yeah, definitely. I can't. That's the beauty of some of these codes. It does require improving without a doubt. But we need to analyze, yes, it requires improvement to what regulations, or is there a potential danger there? Or do we just need to investigate further first? before we fail that installation. And I think more time and effort and energy needs to be tracing those earth cables. So if you're with a customer, it's, look, I'm failing the installation based on the fact I need more time to ascertain and verify the configuration and the bonding setup and the earthing setup. And by the way, I need to contact the DNO and inform them that this is shite.
Yeah, I mean, those earth cables need to be tied up and labelled.
Yeah, because this could have been a temporary. It almost looks like someone's wrapped it in a heat shrink bin liner. Okay. Whatever was in the back of the van. Right, so just a quick one. So that's the end of the photos. I want to go through a few little bits of text, if that's okay, and not many. So this is from the DNO intake document, 26th of February. Domestic commercial. An external intake position is the UK Power Networks preferred option. So we've shown some meter boxes in this. And a lot of people on social media have asked the question, why do I have external meter boxes? I want them inside the house.
Yeah.
So the reason being is, and this is in the standards that are publicly available, it reduces the risk from fire and complies with Southampton Coroner's Rule 43, which, Dave, you have mentioned before on your webinars regarding premature collapse, which is where the coroner can write to various bodies and say, please improve. There's a recommendation dated 28th September to minimise the use of internal meter positions in domestic properties and prevent failure, personal injury and or fatalities.
It's worth mentioning that we do see a lot, and we've got an archive of them, which we can't make public, of DNOs that are catching fire.
We do.
And this rule, you know, again, if you have a fire and the DNO is a cause, this will come up. We may get to a point in 10 years, 15 years where we start observing, oh, the intake is in the property. Recommend improvement.
Question for everybody on the text chat. How many fires do you think there have been in the last 10 years around DNO intakes and metering? So that's just an open question. Just put a random number in there, like calling out lottery numbers.
And not Sparky fault for poor workmanship. Nothing to do with electricians. This is DNO stuff.
Lots is not an answer, but it's a good attempt. Right, so let me finish reading this. It removes the need to install UK Power Networks cabling in customer premises. It allows for 24-hour access to UK Power Networks and the meter operator, which has been known to be dangerous because the meter operators in about 20 years ago were quite naughty. They were going and pulling installations on full load, and there was an incident where somebody who was connected into some home medical equipment nearly got killed because of it. And it provides standard minimum cost solution. Oh, hang on. So therefore, all suppliers to domestic premises shall use an external meter position unless written approval from the Director of Asset Management is obtained. So if you can get in touch with that person, in fact, I think in the next one, we'll put his details and his email. So if anyone wants to put a meter inside their house and you can guarantee LSOH this and, you know, talked connections and all the rest of it and enclosures, and then, yeah, that's the reasoning. I thought it was a fantastic gem of knowledge to insert in here for your jobbing sparks and your electricians and your managers if you don't want to read through all the documents. This is quite an interesting comment. S&E services, so separate neutral and earth, what we know as PILC, paper insulated lead, TNS to sparks. Where a separate neutral earth is to be completely or partially replaced and the premises supplied has a cable sheath, TNS earth terminal, provided by UK Power Networks, that includes the clamps, by the way, the customer shall be given the opportunity to have a PME earth terminal made available where practicable. I wonder how many customers are spoken to by the DNOs and offered a PME earth terminal, because I'm pretty sure that number's 0.
Yeah.
If this option, we're given options, everybody, is chosen, it will be necessary for the customer to arrange for their installation to be checked to ensure it's suitable for connection to a PME network. Really? And for a new service cable to be installed by UK Power Networks. Okay, that's interesting. If the customer does not wish to adopt PME earthing, the existing single neutral earth and TNS may be retained. Are we ever given a choice?
No.
We never are, and yet they're going against their own standards. We're not consulted, we're not informed. We're not asked, by the way, I'm connecting you to a PME, so that 6 mil earth has now got to be a minimum 10 mil. Oh, and by the way, if you actually look at our standard, if it's the end of a branch, it's got to be 16 mil. Nobody ever asks us any of this. So this is where there is a good volume of knowledge available freely in the DNO. So wherever you live around the UK, I suggest as a piece of research, you go away and you read up on your local network stuff. Yes, look at energy networks, but also look at your local network stuff. I think I left this in because earthing, I think I left this in because this is left over from the last one. So apologies, but it's again, bonding of related services, which may or may not be part of a future debate that we're going to have. Yeah, see some earthing slides. So I thought I'd also kind of in the last webinar, we kind of touched on some really controversial stuff, didn't we? At the end, a picture of a few three-phase cutout, some fuses removed and still current. So what I want to do is I want to play this video. If
Did you have an answer about how many homes?
How many what?
You asked chat about how many homes do you think fire, etc.
Oh yeah. Sorry. Well, while that video is playing, please enjoy the arcing of the video. What have we got here? 150, 500, 600, 166, 1666. I like what he did there. 10,224 a year. 6622 between 2000. I'd love to know where you're all getting your numbers from. I happen to know at one DNO there was about 159 within that space at that time because we have photos of all of them. But yeah, so you times that by 13 DNOs or the 8 or whatever there is now, you're probably heading up to thousands.
Daniel's just pasted a good block of text there. 6,622 between 2011 and 2012 alone.
Source ignition. Oh wow!
According to fire statistics.
Right. Can you email us that separately, Daniel? Because we'll add that. Forensics of sufficient resources to forensically investigate each fire, a specific causation. Hence, many fires suspected to be electrical in origin are recorded as appliance faults. Off-gem. Oh, interesting. Okay, so for those watching on YouTube, Daniel Casey's put a really good bit of text in. Daniel, if you could send that to us, please. I don't know if you can. You're still watching the video on the screen, but the video shows a padlock. It's a phenomenon known as tracking. This is where neutral currents will just divert. Common theme there to various places, and you'll see visible arcing, sparking, and that's what you see on the padlock because that's a high impedance joint. But there was sufficient energy and voltage pushing that across. Should we end this with the video that we, should we just end it with the video? What do you think, Dave?
Well, I mean, if you wanted to, right. So for everyone watching on YouTube on demand, we're going to stop this now.
So now we can talk about stuff. They leak voltage, indeed.
They do indeed. And we've got an archive of fires that's been the cause of.
Now, can you guys see the document I've just put in front of the screen?
Yes.
Right. So it's now the high level process for determining. Yeah. Can you see that?
Mm-hmm.
Okay, great. Cool. So this document here is the Energy Network Association Distribution Network Operator Cutout Types and Rating Guidance. It's intended to assist EV charge point installers, basically. And if I zoom out a little bit, it's got MOPCOA guides and all the rest of it. But what it does do is it's really nice. This is a great, if you've got an apprentice, this is a guide to help teach your apprentices what to look for on cutouts. So you've then got the modern cutout, which is GRP. Wonder why? Phenolic. And the installer must assume it's 60 amps. If it's if the installation designer's calculation confirmed, then you've got black plastic, phenolic. Metal clad cutout, 1940s, 1960s. But what it does is it gives you advice on the loading. It then goes back into the biscuit tins, 1930s, 1960s. Embargoed, neutral cutouts. We've got live fused neutrals. Loop services, bottom and top. Modern services cutouts. In GRP enclosures, 68 or 100 amp versions. Again, look at that. I mean, why would a human being do that? I'm stunned that they've actually put that in. That just shows you whoever put this document together is evidently brain dead. But yeah, they've just put basically, oh no, hang on, what they've done, they've put an RCD main switch, rotary isolator, RCD, and a circuit breaker. That must, is that a PV connection, maybe?
It's a PV system on the isolator.
Oh, God. Yeah. So again, different types of methods and means of cutouts. different configurations. You notice all these plastic, all of the earthing terminals are plastic now.
Insulated, yeah.
Yeah, they're all insulated. They're all insulated. And that's because there's reference to insulating anything which could become charged of energy, which we're going to cover.
Good wording there. Charged. That's, live is charged, which means it doesn't necessarily have a voltage on it. Could be 0 volt, but it can have current flowing through it. And
HSG 85 does define anything that has significant charge as live.
Yes.
So our earthing systems, you could, if you had a clamp meter and were able to measure energy on them, consider them live. BS 7671 has some catching up to do. By the way, hang on a minute. What is that in the corner? Is that what I think? Let me just zoom in. Is that copyright Flameport Enterprises Limited? John, feel free to swear. I've got the beep button on YouTube.
Oh, dear.
Oh, dear. So Energy Networks Association, on behalf of my good friend John Ward, shame on you. So, yeah, this is all publicly available information, chaps, guys and girls, sorry. But what it does do is it goes into quite a significant level of detail. So for those looking for that education and knowledge on cutouts, this is, you can Google it, you can get it on your phone, you can, try and understand what's in these biscuit tins, because I had that on my house for many years, that biscuit tin type, and all the different configurations you get, the embargoed neutral cutouts, loop services, there you go, loop services in and out, neighboring properties. There's some really good knowledge, and this is a great one. High-level processes to determining suitability of cutout for additional load. On the right-hand side, if it's metal, bad condition, 30s, 60s, nope. It's embargoed, nope. And if it's loop services, nope. So how many people have put an EV installation onto a loop service when this document says you shouldn't?
John, did the EV course in any way tell us to look at the actual supply intake equipment assembly, or is it just PME, TNCS, TNS? Did it ask us to look at any of those? John?
Sorry, what was that? I was distracted by
You,
something else.
you've just done your EV course. Did they ask you to look at the switchgear in the way that's just been described there?
Not in any detail. The course was a bit condensed, shall we say. It's
okay.
Day affair. One of those was obviously the assessment and the testing stuff. But
condensed, including your assessments.
Yeah, basically, if it's 60 amps or less, including the EV charger, then you can just go ahead and install it. And if it's above that, then you need to speak to the DNO first. So unless it's a very, very low powered property, you're going to be speaking to DNO first, because 60 amps, bear in mind a typical EV charger is going to be 32 or 30 amps anyway. That only leaves you 30 for the whole rest of the property. So so in most cases, it's going to be over that 60.
This says, John, if presented with the above types of cutout, the LCT device installer must assume that the cutout is unsuitable for additional load, or that the fuse size in the cutout is 30 amp. In all cases, the installer must refer the matter to the DNO for an assessment to be carried out and possibly a cutout replacement.
Yeah, the loop services one. Basically, if you come across a loop service and they want an EV charger, then it's unfortunately game over in that regard, because they're going to have to unloop it, which is going to mean probably a load of money spent in some part of it.
Did the EV course tell you that?
That was, I don't think that was included. I kind of knew that anyway. So
you kind of knew that anyway.
Well, then it's a spend on the network that they're not going to want to pay out for someone who can afford an EV car.
That one it's basically the 60 amps thing is mentioned. But so if you think about it, if you're putting in a 7 kilowatt charger, which is sort of 30 amps, the fact that you've only got 30 amps in total for everything else that's already in the property is not a lot. Mm-hmm. So you only need like one electric shower, and there you go. So, you're over the 60. So, yeah. And also, you need to find out what the rating of the main fuse is anyhow, because just because it says 100 amps on the label doesn't mean it's 100 amps inside. It could be who knows what. So, in most cases, you're going to have to contact the DNO anyway. So, the other thing which was in the course is the fact that if you're putting one in, it's not necessarily just the loading on that individual property. So if you go to, say, a block of flats, you've got to consider like the total loading for that particular like local area. So if you go to block of flats and 6 people want an EV car putting in, then individually per flat, it might well be you could get it under the 60. But ultimately, if you're putting like 3 or 4 in one individual location, then it's contact the DNO again, because obviously it's a large amount of load you're actually adding onto the system. So,
Gotcha.
yeah. So it'll end up as you contact the DNO first, just to make sure anyway. And then if you can go ahead, well, fine. And if not, they need to make alterations. So.
I think you've nailed it, John. I think this is the trouble, is stuff's getting more complex. Just looking at the comments, Daniel said Zappy load curtailment. Yeah, I quite like the Zappy bit of kit actually. Where was it? Matt Ralph has said loads of biscuit tins in Stevenage. Harlow is filled with biscuit tins. They are absolutely everywhere. They're a bit of a nuisance. I had one in my house quite some time. What else is any other comments? Sorry, I'm just reading through now. 1 second. Somebody wants a reference for the document. So it is called Cutout Rating Guidance to EV Installers. It's the March edition. There's lots and lots of information about. It's just finding it. And again, all this is Googleable.
Googleable. Do we? I mean, some of you guys are from the Discord. We can drop some of these free ones into the Discord, can't we?
Somebody in the comments, I can't find it now, asked what is Discord, as they don't know. Oh yeah, Richard Corey.
It's a secret.
It's just it's kind of like a forum kind of place. If you click, you go on my website, sparkyninja.com, and then there's a Discord thing. You click that and you get an invite, and you can just run it and you create a little login. It's just like a forum, but it's different.
Yeah, it's basically full of people who are really nice.
It's where a lot of people in this chat hide and kind of tell us what we should be talking about in these things.
The point being is, though, this is getting more and more complex.
Yes.
And I think we as individuals are realizing it's more complex. There's more knowledge that needs to be produced. Cripes, you could write a book on DNO intakes alone for electricians. You could write a book on diverted neutral currents, which is what we will touch upon more in the next one of these webinars, because I think it's worth covering on these webinars some more before and afters, going over some of these bits. Going through this document. It would be really good, actually, if everyone watching this, go away and do some research, find some nuggets that you want discussed, and we'll then put it into a part 2, and we'll have an open debate about it. Because I'm reading these documents and I'm blown away by some of the stuff I'm reading. I mean, let's see if I can. Oh, I've just closed.
And you're right, though. It's a lot of information, and what we can't do is just say, "Here, have all this information." We need to obviously allow people to take the time and actually kind of go on.
So let me read something from BS 7430 out to you. Part 20, consumers electrical installations. 2 hazards may be present should an earth fault occur in an installation. Firstly, voltages appear between conductive parts. Yep, we know that. They constitute a shock hazard. Funnily enough, was termed indirect shock. We don't use that term anymore. We use basic and fault protection. The severity of any shock depends on other factors, type of current, AC or DC, the magnitude of these voltages, and the time for they're allowed to persist. Secondly, the earth fault current may be of such magnitude and duration as to cause excessive temperature rise in conductors through which it flows, thereby creating a fire hazard. Now, why just fault? Because it's fairly evident, if you looked at the picture last week, the diverted neutral current issue, it's not fault, it's normal. Diverted neutral current is large levels of excessive neutral current appearing on earth systems, which can cause temperature rise. That's in BS 7430. So I'm reading that. For anyone who else wants to know, on the 13th of August, there was an energy, Scottish Power Networks guy who was involved on a low voltage jointing incident. He died, age 32. That's safety alerts on our Instagram. There is 1 or 2 other bits if I can find it. No, I can't, because my computer's all over the place, as per usual.
Yeah. Now, as Daniel says, it's difficult to suddenly get a huge mass, to digest this huge massive dump of information. Hard to know where to start. It's the same for us, buddy. What we kind of do is we kind of binge on it, and then we kind of go on with the things. And we return to them. I mean, Paul's over the past couple of days kind of highlighted how he prints off, highlights, he scans, and then he revisits. And it's pretty much the same. I mean, we've got so many documents and references. I'm trying to reorganize them all on my end because
these shelves behind me
so many.
are just going to fill up with British standards. That's all that's going to happen. They're just going to keep filling up. And I'm just going to keep reading them so that I can have them actually accessible. So I can just turn around and grab them off the shelf.
And as we've said in competence discussions, we're not supposed to memorize all this. We just need to know the information is there and know how to access it when we need to.
Yep.
You know,
the part of the journey, one of the first parts of the journey is knowing the standard exists. If you know the standard exists, you're halfway there to winning. And that's key. The rest of it is then understand the big words that we may not use every day. But I think it's technology that is being connected to aged infrastructure is causing multiple issues. Let's look at it.
Definitely.
Faulty white goods, arc fault, surge protection, transient. So next week we're doing surge. So surge protection is going to be an interesting one because we're going to talk about strikes and strokes. We're going to go through some pictures. If anyone's got any pictures of any good SPD installations that are pants, please send them, because we're kind of reverse engineer the whole surge protection argument rather than doing it the way the regs wants us to do it. And Kirsty will be joining us for that. And she won't see.
And it's a good idea though, because it allows us to reapply the way the regs want us to think about it.
Yeah.
If we try to think about things differently, it helps us to understand what it wants us to do.
Yes, absolutely. It's just trying to take things from different angles. Is there any thoughts or feelings?
There are 3 questions in the Q&A. Okay, so Dave Betteridge says, seeing a few pics here where bending radius or more of a coil, you know, your little coils that you love, you know, pigtails. Is there a reg or a standard that doesn't allow such practice? He's thinking things like thermal spots or inductive effects. I know you really don't like these little coils that you get in boards with the mains.
Oh, the helixes. Yeah, the helixes are just awful. Pigtails.
Can you think of any standard or any criterion that you could refer to that would be detrimental to? You know, if you were to code it JS, just shit, that's great.
No, I would talk about the bending radius of conductors. Oh Christ, I can't remember where that is now. Hang on.
Yeah, this is the thing where you got like your like bonding conductor and someone's wrapped it around a broom handle first, haven't they? And stuck it into the terminal.
We used to always do that though, because remember cage bonding and supplementary bonding, we'd get the old hammer.
That was fine. That was fine if you wanted to do that, but the only time I ever was taught to have that against vibration.
Yeah,
that was basically it. It was vibration and motors, and that was the only thing in 20 years ago. Now, why you would put these helixes in, all these pigtails.
We have other cable types now. You know, we have other options now, don't we?
It's a waste. I will dig out the reg numbers and bits and bobs and the argument for it for when we do the second part of the DNO. But good challenge, because there is regs in it, and it is all to do with bending radius of conductors. But yeah, and it's, to be honest with you, I would just use good workmanship materials, 13411 or whatever it is.
Usual one that everyone forgets.
Usual one everyone forgets. Good workmanship and materials. But how do you define that? Building Regulation 7, which very clear on good workmanship materials: straight, square, level, flum, flush, in line with manufacturer's agreement.
The other one from Simon Goodship is it's kind of along the same lines. It's about bending radius. So we've got tails entering the consumer unit, and again, yeah, bending radius does matter. And if you check with the actual cable manufacturers, they'll tell you what the minimum is, and it's normally so many diameters of the cable.
Exactly. The manufacturers will give you specifications about that. Wiring regulations gives you things under wiring systems where you've got risks of impact, and it will mention things like tension, compression, and things like that. And if the connections
placed upon conductors,
strain,
Well, the fact of the matter is, there's a reg for you must follow manufacturer's instructions. That includes cable ones. Cable manufacturers will say to you, there's a bending radius for external diameter and internal core diameter, if it is like an armored and stuff. I can't remember them off the top of my head. I'm ashamed to say it, being 10 o'clock at night, which awful of me. I used to know this off the top of my head. But yeah, so there is manufacturer's guidance. That manufacturer's guidance is a breach of the manufacturer's guidance reg. Never mind the good workmanship materials. Never mind the strain placed upon conductors regulation. So there's 3 regs straight away that those meter tails. I can't stand when I look at a consumer unit online. The first thing I do on Rate My Board is look at the bending radius, and the amount of people who bring tails in the bottom, round the back of the main switch, and complete horseshoe up. Straight away, I think to myself, if I got the manufacturer's data for the bending radius of those cables and just dropped a line down the middle and measured across, I guarantee you I'd be in breach of that bending radius.
It'd be too sharp.
Of course it would be too sharp.
Yeah.
The rule for bending radius of cables was no horseshoes. You never do a horseshoe on a cable, ever. And yet most people do. It was something I always wanted to do a webinar on, but I just never got the time to do all the research behind it. To be honest with you.
There's many things, isn't it?
Somebody in the chat has said, can I have an E5 sticker? What, one of them ones, you mean? Quite nice, aren't they? Yes, you can. Just ask and wait a very long time, because I've got like 900 emails in my email box now. In Liam Neeson's voice, please can you say strokes are worse than strikes? No, I can't do it. It's 10 o'clock. I will do on the next one, okay? Oh, God, it's definitely getting late, isn't it?
What does Dean do about an E5 sticker? Where's he send an address to?
info@e5group.org.uk.
Okay.
And please include an address, because I'm not a mind reader. I have sent probably 2,500 emails to people saying, hello, I'm not a mind reader. Please, can I have an address? Which would be nice. So yes, I can send you. What one would you like? Would you like the small reflective one for your regs books, or the clear ones, or the larger ones? We have every type. So let us know. Any other questions?
David has said, wondering on the second part, or maybe now up to you as it's late, put PNB examples would be great to an understanding of. So examples of PNB.
Yes. So the reason why we said on social media this was going to be 10 hours is because if we did examples of PNB, we would then have all the diagrams and all the schematics and everything else. And I'll tell you what we'll do for the next one. Rather than at the start have the earth clamps and all the rest of it and 9.5, we will put all of the schematics and we will dig out photos of what a PNB connection should look like. And we'll do some more where we show you an intake and let you guess, and you will guess wrong. But it will kind of add more to this debate of these DNOs are quite complex and they don't always follow their own rules.
I think what's obviously evident, especially from tonight's webinar, is there's so much information available, yet we haven't been shown it, or we haven't been educated into where to find it. Yet we're now being we're being asked to express our opinions on the condition of the installation with no real understanding on what their standards are.
And that is the PME supply cable that goes into most houses nowadays. That's it. That aluminium core, that copper external. It's tiny. When you think about it, the only thing reliable in that cable is the live. The outer is the neutral and earth. And
you can see now why neutral currents may end up getting lost.
Onto
diverted.
Diverted. Heaven forbid.
Through the gas meter. Yes.
Yeah, but on a serious note, these webinars are to try and help expand your knowledge and us to share our knowledge. If it's been helpful, thank you very much for watching. And we will definitely do a follow-up on this one, because there's a lot more to go, a lot more knowledge to share. We would like you guys watching this to share your knowledge of us. info@e5group.org.uk, because this is about us as a group debating and talking.
Or in a Discord where you can talk to each other about it.
Bloody self-indulgence, Dave.
Oh, nice.
Oh, hang on, what's that? Of the DNOs, it's just coiling the cable for PME. Is there a step potential voltage from not being deep enough?
Yeah, there could be, depending on how deep it was and if that was connected at the time. So
I'm pretty sure I've got some pictures of recent torpedoes where they've just got little bits of spray.
I've seen it where they've just put the thing on top of it, you know.
Yeah, normally they go under to actually keep it level while they're doing it.
Yeah.
Like a platform. You've got an electrode, if it's in the ground and there's obviously a fault there and the current's flowing, then you could have a step potential from that to wherever it happens to be. So
just to let everyone know, next Wednesday is going to be slightly different. Although it's called EICR coding SPDs, 20% of it's going to be coding. The rest of it is going to be reverse engineering surge protection. Okay,
which is really what you want to know, though. You want to understand that. Yeah, it's what we want to know.
We know the regs. Let's take everything from it's there and let's go backwards and see if we come up with a different result.
We'll do some coding for fun, because there are some serious situations where we may need to code with the absence or presence of an SPD. But a lot of the time, Kirsty's coming along will be to actually gain, hugely in stepping backwards with this.
Yeah, and there is, I think it's fair to say, there is future webinars we want to do and desperately want to do, but there's certain restrictions on knowledge that we can share in this. I think we've pushed boundaries enough as it was. Yes. But there is lots more we want to tell you, and we're not legally allowed to tell you as of yet. But the minute we do, we will blow your socks off later on this year, I think it's fair to say. But this, I think it's also fair to say, is going to somehow have to change the way we operate, or at least the regulations or the information. Because let's be perfectly frank, the ECA, the NIC, NAPIT, if they're not putting this knowledge out there, let's put it out there for ourselves.
Yeah.
It's free, it's public. We should be getting told what we're paying our money for.
Yeah.
Just a thought.
Yeah, I mean, and at the end of the day, a lot of this stuff is used for their own kind of gain, books, publications, all this stuff. There's so much stuff available for free. We just don't know where it is.
It is, indeed. Other than that, thank you. Sorry for being so long. Please don't abuse us down below.
Please be nice.
TW, you're a legend.
Cheers, John.
David. As always.
Right, everyone in chat, thank you for coming along. I'm going to hit the end button unless there's anything else you guys wanted to quickly say. Hopefully not, because we've been 3 hours.
Peace and love.
Right, cheers guys.